Tonight's episode was suggested by Jared Sullivan. Thank you, Jared. This one turned out to be one of the strangest rabbit holes we have ever gone down, and that is saying something. Drop your location in the comments below and let us know where in the world you're listening from tonight, as we love seeing how far this community reaches. Before we begin, a quick note. If you're watching this on YouTube, we are so grateful you are here. But YouTube does not monetize this channel. The single best thing you can do to keep Sleep Theories going is to find us on Spotify. The link is right there in the description. It takes about 10 seconds, it costs you nothing, and it genuinely makes an enormous difference. Sleep Theories on Spotify is what keeps the lights on. Okay, now let us go somewhere very cold, very dark, and very strange. Act 1. The End of the World. There is a place on this planet where the sun does not rise for 6 consecutive months, where the average winter temperature falls to 117 degrees below 0 Fahrenheit, where the nearest hospital is more than 800 miles away, across frozen ocean and mountain ranges that no vehicle can cross, where if something goes wrong, nothing can reach you, where during the darkest part of the year, you are as alone as a human being can be while still standing on Earth. That place is the Amundsen Scott South Pole Station, and for roughly 44 scientists and support personnel who winter over every year, it is simply home. The station sits at the geographic South Pole, the single point on Earth around which the entire planet rotates. It is built on top of nearly 10,000 feet of ancient compacted ice, not frozen ground, not permafrost, ice. The continent of Antarctica is not a landmass covered in ice the way Greenland is. It is in many places ice so deep and so ancient that the bedrock beneath it has not seen sunlight in tens of millions of years. The ice at the South Pole is more than 15,000 feet thick in some locations, and it has been accumulating layer by layer for time spans that the human mind is not well designed to comprehend. During the Antarctic winter, from approximately March through September in the Southern Hemisphere calendar, the station exists in complete isolation. No aircraft can land. The air is so cold that jet fuel behaves unpredictably. Even the most modern cargo planes used in Antarctic operations have hard temperature limits, below which landing is not attempted. Once winter begins, the crew that is there stays there. No one new arrives, no one leaves. They are sealed into one of the most hostile environments on the surface of the planet, sustained by supplies flown in during the preceding summer months, waiting for the light to return. People who have wintered at the South Pole describe a unique psychological experience. There is the obvious darkness, the extreme cold, the enforced proximity to the same small group of people for months on end. But there is something else that researchers and station veterans describe more rarely and more carefully. A quality of the silence that feels different from ordinary silence. A sense that the ice itself is not simply absent of sound, but is producing its own presence. A low, almost subsonic awareness that you're standing above something extraordinary, something ancient, something that has been beneath you for longer than your species has existed. Most people who work at the South Pole assume that feeling is simply the brain making meaning in a sensory-deprived environment. The human mind is pattern-seeking. It will find patterns in anything, including silence, including ice. That is the rational explanation, and it is probably correct. Probably. Because buried beneath that ice, operating continuously through every winter darkness and every summer brightness, sits one of the most unusual scientific instruments ever built by human beings. An instrument that officially exists to look outward, toward the stars, toward the far edges of the universe, but which, according to people who have spent years examining its data, may have been built, at least in part, to look in an entirely different direction. Downward. Act 2. The observatory that should not work. The IceCube Neutrino Observatory is, by almost any measure, one of the most ambitious scientific constructions in human history. Not because of its size, though it is enormous, not because of its cost, though it is staggering, but because of what it is made of. IceCube is not built from steel or concrete or glass or any of the conventional materials of large-scale scientific instruments. IceCube is built from ice. Ancient, compressed, extraordinarily pure Antarctic ice, more than a mile below the surface of the polar plateau. The concept behind IceCube is elegant in its physics, even if it is difficult to visualize at human scale. Neutrinos are among the most common particles in the universe. Trillions of them pass through your body every single second. They are produced by stars, by supernovae, by black holes devouring matter, by the collision of cosmic rays with the upper atmosphere. They travel at nearly the speed of light, and they interact with almost nothing. You could fire a neutrino through a wall of solid lead 1 light-year thick, and the neutrino would still have a better than even chance of passing straight through without touching a single atom. This makes neutrinos extraordinarily useful for astronomy. Because they travel in straight lines, pass through essentially all matter without deflection, and maintain their energy signature across cosmic distances, a detected neutrino is like a message sent directly from whatever cataclysmic event produced it, travelling billions of light years across the universe without being scattered, absorbed, or distorted. If you can catch one and measure it, you know almost exactly where it came from and what kind of event created it. The problem is catching one. Because neutrinos interact with almost nothing, detecting them requires something enormous, something with enough target mass that at least a few of the trillions of passing neutrinos will occasionally, improbably, strike something and produce a detectable signal. IceCube's solution was to use a cubic kilometre of ice as a detector, a cubic kilometre, 1,000 metres in each direction. The facility drilled more than 86 shafts into the polar ice, each one approximately 1 mile deep, using a specialised hot water drilling system that melted a path downward and then filled the resulting hole with strings of sensors called digital optical modules. Each string carries 60 such modules. In total, IceCube contains 5,160 optical sensors, suspended throughout a volume of ice so enormous that entire mountain ranges could fit inside it. When a neutrino does strike a water molecule within the ice and produce a secondary charged particle, that particle travels faster than light can travel through ice, producing a blue flash of Cherenkov radiation, the optical equivalent of a sonic boom. IceCube sensors detect that flash, and from the timing and distribution of the light across thousands of sensors spread throughout a cubic kilometre, scientists can reconstruct the direction, energy, and likely origin of the original neutrino. It is, by any reasonable assessment, a staggering achievement of physics and engineering. The facility has contributed genuine, peer-reviewed, Nobel-caliber science to human understanding of the universe. It has detected high-energy neutrinos from distant blazars. It has contributed to multi-messenger astronomy by combining neutrino data with gravitational wave and electromagnetic observations. Its data is published openly and studied by thousands of physicists worldwide. And yet, something in the data does not fit. Something that the official scientific literature has acknowledged, debated, and never fully resolved. Something that, in the version of events we're exploring tonight, a young astrophysicist named Dr. Owen Mercer noticed while reviewing archived detection logs during his second winter at the South Pole. A something that began as a statistical anomaly and became, over the course of the months that followed, an obsession that would cost him colleagues, credibility, and finally sleep. Dr. Mercer was not looking for anything unusual when he found it. He was performing routine data quality verification, the kind of careful cross-checking that junior researchers do to ensure that instrumentation is behaving as expected before anyone runs meaningful analysis on the results. He had spreadsheets, he had algorithms, he had several months of polar winter ahead of him and nowhere else to be. He was comparing the directional distribution of detected neutrino events against expected backgrounds when he noticed the pattern, or rather, when his statistical software flagged an anomaly that he initially assumed was a coding error, because the numbers, if he was reading them correctly, were suggesting something that the physics simply did not allow. A subset of the detected events appeared to be arriving from below, not from space, not from the sky, from beneath the earth. Act 3. The upward signal. Here it is important to be precise about what the science does and does not permit, because Dr. Mercer's anomaly only becomes interesting once you understand how unusual it truly was. IceCube does, legitimately and intentionally, detect neutrinos arriving from below. This is expected and accounted for in all standard analyses. Neutrinos produced by cosmic ray interactions in the northern atmosphere can travel through the entire Earth, all 14,000 kilometers of rock, mantle and molten iron, and emerge at the South Pole still moving, still detectable. This is one of the instrument's actual research programs. Because the Earth itself acts as a filter, blocking lower energy particles but allowing very high energy neutrinos to pass through, detecting upward moving events gives scientists a cleaner sample of the highest energy cosmic neutrinos, because everything else has been absorbed. So upward moving neutrino detections at standard energies are not only unsurprising, they are the intended product of certain IceCube research programs. What Dr. Mercer found was different. The events he flagged were not arriving from the north, through the Earth, as would be consistent with cosmic ray interactions in the northern atmosphere. They were arriving from almost directly beneath the station, from a bearing that corresponded to a point roughly 200 to 300 kilometers south-southwest of the South Pole itself. And their energy signatures were unlike anything in the expected backgrounds. They were too low energy to be standard atmospheric neutrinos. They were too precisely directional to be instrument noise. They were too numerous and too consistent to be statistical fluctuation. And they had been appearing in the data for years. Not every day, not on any predictable schedule at first, but consistently enough over the full archive data set that their presence was unambiguous once someone looked for them specifically. Mercer spent 3 weeks checking his analysis from every angle he could imagine. He rewrote his detection algorithms twice. He pulled the raw sensor logs and checked them against the processed dataset to make sure he was not looking at an artifact of the data pipeline. He asked a colleague in the data quality group to independently verify his methodology without telling her what he expected to find. She found the same anomaly. She also told him to be very careful about who else he mentioned it to. That conversation, Mercer would later write in notes that were not intended for publication, was the moment he began to understand that he was not the first person to have found this, that the anomaly was not new, that it had been noticed before, and that someone had made a decision about what to do with that knowledge. The decision that had been made was nothing. Nothing official, nothing published, nothing acknowledged in any peer-reviewed paper or institutional report that Mercer could locate. He began to understand that the absence of published work on the anomaly was itself a kind of data point, and it was pointing somewhere he had not expected to look. It was pointing backward, to a project that had concluded more than 40 years earlier, to a survey mission conducted during the Antarctic summer of 1973, under a program with a name almost no one remembered. A program called Deep Echo. Act 4. Deep Echo. The 1970s were a period of intensive Antarctic survey work. The continent had been open to international scientific cooperation under the Antarctic Treaty of 1959, and the superpowers, while officially committed to peaceful scientific collaboration, were simultaneously conducting extensive geological, geophysical, and magnetic surveys of a continent that no one had ever properly mapped. The Cold War created a peculiar dynamic in Antarctic research during this period. Cooperation happened, information was shared, scientific data was published, and yet certain programs remained poorly documented, operating in the ambiguous zone between pure science and strategic intelligence gathering that characterized so much research during that era. Deep Echo was one of these programs. Its official description, in the limited records that Mercer was eventually able to locate through Freedom of Information requests and declassified government archives, described it as a geophysical survey mission focused on subglacial topographic mapping in the East Antarctic interior. This was routine work. The Antarctic bedrock beneath the ice was poorly understood, and knowing its shape and depth was scientifically valuable for understanding ice sheet dynamics and glaciological modelling. The survey team deployed in November of 1973 and spent approximately 6 weeks in the field, using a combination of seismic sounding, airborne magnetic surveys, and ground-based gravitational measurements to map a section of the East Antarctic Plateau, approximately 400 kilometres across. Their equipment, by modern standards, was crude. By the standards of 1973, it was state-of-the-art. Most of what they found was what anyone would have expected: ancient bedrock, subglacial lake systems, magnetic variations consistent with known geological processes, a continent doing exactly what continents are supposed to do when they have been frozen and isolated for millions of years. Then, in the 4th week of the survey, in a region approximately 240 kilometres south-southwest of what would later become the South Pole Station, the instruments found something that was not consistent with any geological process that anyone on the team could identify. The seismic returns showed an anomaly approximately 3 kilometres below the base of the ice sheet, which at that location meant roughly 4.8 kilometres below the surface. The anomaly had a shape that the team's geologist described in the draft field report that Mercer located in an obscure archival collection as inconsistent with any known depositional or tectonic formation. The return pattern was too regular, too symmetrical. In 3 dimensions, the shape appeared to be roughly hexagonal in its primary cross-section, with subsidiary geometric features that the seismic resolution of the era could not fully resolve but which appeared to repeat at consistent intervals. Natural geological formations can sometimes produce striking symmetries. Columnar basalt, for instance, forms near-perfect hexagonal columns when lava cools at the right rate. Crystal formations can be geometrically precise at small scales. There are geological phenomena that produce shapes which, to an untrained eye, might appear artificial. The Deep Echo team included experienced geologists. They knew all of this. They noted every alternative explanation in their field documentation, and then they noted why each alternative explanation did not fit the specific characteristics of what they had found. The object, if object was the right word, was too large. The geometric regularity extended across too great a distance to be explained by any known crystalline or volcanic process. The depth was unusual, and most troubling, the magnetic measurements over the same location showed a pattern of electromagnetic activity that was inconsistent with passive geological material. The anomaly appeared to be producing a signal, not constantly, not strongly, but repeatedly. At intervals that the team's instruments could detect but not precisely measure, because their monitoring time at that location was limited, and their instrumentation was not designed for this kind of detection. The draft field report containing these observations was never formally published. The final version of the Deep Echo survey report, the one submitted to the funding agencies and placed in accessible scientific archives, contained all of the routine findings and none of these. The anomalous section of the survey was omitted entirely. Where the instruments had recorded their most remarkable finding, the final report simply noted that instrument calibration issues affected data quality in the southeastern quadrant of the survey area, and moved on to other matters. The draft report survived, by accident, or perhaps not entirely by accident. It was found in a collection of personal papers donated to a university library by a retired geophysicist who had not been part of the Deep Echo mission, but who had received a copy through channels that were themselves not fully documented. How it reached him was not recorded. Why he kept it, tucked inside a folder of field notes from an unrelated Antarctic expedition, was also not recorded. Dr. Mercer found it during his 3rd month of searching. He read it twice in the same sitting. Then he sat for a long time in the Antarctic night, with the ice pressing down from above and the continent pressing up from below, and thought about what a geometric electromagnetic anomaly 3 kilometres beneath the bedrock had to do with the directional neutrino detections he'd been analysing for the past several weeks. He thought about it for a long time, and then he began looking at satellite data. Act 5. What the satellites saw during the Cold War, both the United States and the Soviet Union operated extensive satellite reconnaissance programs over Antarctica. This is documented, declassified, and not particularly controversial. The strategic logic was straightforward. Antarctica represented a potential theatre of operations if the Cold War ever went hot. Understanding the continent's geography, ice dynamics, and infrastructure was standard military planning. Both superpowers photographed the continent regularly and analysed the imagery carefully. Much of this imagery has since been declassified, at least partially. The resolution of Cold War-era reconnaissance satellites was extraordinary for their time, and some of the imagery released through declassification processes reveals a level of Antarctic monitoring that goes well beyond what standard military planning would require. Certain regions of the continent were photographed repeatedly by multiple satellite systems across decades of observation. Some of these regions had no human infrastructure, no strategic value in any conventional military sense, and no obvious scientific significance that would explain the intensity of the monitoring. The region approximately 240 kilometres south-southwest of the South Pole was among the most consistently photographed locations in the entire dataset. Mercer's access to this imagery came through an unusual chain of contacts. A colleague who worked in geospatial analysis had relationships with former intelligence community researchers who had participated in early declassification review processes. Through this network, Mercer gained access to several hundred images spanning from the mid-1960s through the early 2000s, all of them focused on or near the region identified in the Deep Echo survey. The images themselves showed nothing dramatic. Ice, more ice, the occasional surface feature caused by wind-driven snow accumulation. Nothing that would attract attention if you were simply looking at photographs of Antarctica. But the images also showed something that the ice could not hide from careful analysis. A recurring thermal anomaly, not a large one, not one that would show up on standard resolution imagery. But in the higher resolution frames, captured at specific times of year when atmospheric conditions were favourable, a faint but consistent thermal signature was visible over an area roughly consistent with the location of the Deep Echo anomaly. Thermal signatures on the Antarctic ice surface come from 3 primary sources: solar radiation, geothermal heat transmitted upward from deep below the crust, and human activity. The signature Mercer was looking at was too small and too consistent to be solar variation. It was too localised and too structured to be standard geothermal activity, which tends to produce diffuse gradual thermal gradients rather than discrete patches, and there was no human infrastructure anywhere near the location during most of the period covered by the imagery. The signature was something else. Over the 40-year span covered by the imagery, it remained in approximately the same location. It did not drift, as a geothermal anomaly might as the ice above it slowly moved. It did not grow or shrink in ways that suggested changing geological activity. It remained, with minor seasonal variation attributable to surface conditions, essentially constant. A faint thermal outline, perhaps 300 metres across, sitting quietly in the ice above whatever the Deep Echo survey had found 3 kilometres below the bedrock. Mercer combined the Deep Echo seismic data with the satellite thermal imagery and the directional neutrino detection anomaly he had found in the IceCube archives. He built a simple 3-dimensional model of what the data, collectively, seemed to be pointing toward. What it showed was a structure, not a natural formation, not a geological accident, a structure of extraordinary size sitting beneath miles of Antarctic ice, apparently generating both electromagnetic signals and a subtle but detectable thermal output. A structure that had been there, based on the earliest satellite evidence, since at least the 1960s. And based on the geology of the region, based on the depth of the ice above the bedrock where it sat, since a period of time that predated the current ice sheet by an almost incomprehensible margin, he presented his analysis to the senior researcher he trusted most. The response he received was not what he expected. Act 6. The explanations that do not explain. Dr. Mercer had prepared himself for skepticism. Scientific culture is adversarial by design. Extraordinary claims require extraordinary evidence, and the analysis he was presenting, however carefully assembled, was built on a foundation of archived data, declassified imagery, and a long-defunct survey report that had never been officially published. He expected to be challenged. He expected to be told he had made mistakes. He was prepared to defend every step of his methodology. What he was not prepared for was the quality of the response he received. Not because it was hostile, it was not. Not because it was dismissive, it was actually quite engaged. The senior researcher listened carefully, asked thoughtful questions, examined the data Mercer had brought, and then offered a series of explanations that were, on their surface, entirely plausible. The neutrino directional anomaly could be instrument noise. IceCube sensors are extraordinarily sensitive, and they operate in a physically unusual environment. The ice surrounding the sensors is not perfectly uniform. It contains layers of different optical clarity, laid down in different atmospheric periods that can subtly affect the propagation of light through the detector. These variations are corrected for in standard analysis, but the corrections are imperfect, and at low statistical significance, directional artifacts can appear in the data. This was a known issue. Papers had been written about it. The Deep Echo Survey anomaly was almost certainly unusual geology. The East Antarctic bedrock contains some of the oldest rock formations on Earth, and geological structures that have been subjected to billions of years of tectonic stress, metamorphic transformation, and subglacial erosion can develop unusual properties. Massive crystal formations, ancient volcanic intrusions, unusual mineral concentrations. Any of these could produce the geometric regularities and electromagnetic signatures described in the unpublished draft report. The fact that the final report omitted these findings almost certainly reflected a judgment by the survey team that the anomaly had a geological explanation they had not had time or equipment to fully characterize. The satellite thermal anomaly was most likely a combination of surface albedo variation and instrument calibration issues affecting older sensor systems. Cold War-era reconnaissance satellites were optimized for photographic intelligence, not precise thermal measurement, and comparing thermal readings across different satellite systems from different eras involved systematic errors that could easily produce the kind of pattern Mercer had identified. Each explanation was reasonable. Each one addressed a legitimate weakness in Mercer's analysis. Each one was the kind of response you would expect from a careful, experienced researcher examining an unconventional claim. And not one of them, even slightly, addressed the question that mattered most to Mercer. Why had classified intelligence agencies spent 40 years taking repeated photographs of an empty patch of Antarctic ice? The senior researcher did not have an answer for that, or rather, she offered one. Routine coverage, standard Cold War, monitoring protocols applied uniformly across the continent that Mercer had already checked and found inconsistent with the data. The coverage of the anomaly region was not routine, it was not uniform. It was specifically targeted and unusually intensive compared to surrounding areas with similar strategic profiles. When he pointed this out, the conversation ended. Not dramatically, not with conflict. It simply ended. The senior researcher said she had a meeting she needed to get to. She suggested Mercer write up his analysis formally and submit it through the appropriate review channels. She said she was sure the data quality team would find it interesting. She did not suggest he pursue it further. She also, Mercer noticed, did not suggest he stop, so he did not stop. He went back to his records, and he started looking at the money. Act 7. The funding trail. IceCube is officially a National Science Foundation project. It was funded primarily through the NSF's Office of Polar Programs, with contributions from international partners including Germany, Sweden, Belgium, Switzerland, Japan, Canada, New Zealand and Australia. The total construction cost was approximately $279 million. Operations cost several tens of millions of dollars per year. The science it produces is published openly. Its governance is straightforward academic collaboration. All of this is true and verifiable, and none of it is what Mercer found interesting about the funding history. What Mercer found interesting was the process by which the decision to build IceCube at the South Pole specifically was made. The South Pole site was chosen in part because the ice there is extraordinarily clear. Ancient, bubble-free ice with exceptional optical transmission properties that make it ideal for Cherenkov light detection. This is the standard explanation for the site selection, and it is scientifically valid. But the depth profile of the detector, the specific arrangement of sensor strings, the particular geometry of the 5,160 optical modules distributed through a cubic kilometre of ice. These design choices, Mercer discovered, are not uniquely optimal for detecting cosmic neutrinos from above. They are also, as he worked through the geometry carefully, essentially optimal for a different purpose. For triangulating the precise location and characteristics of a signal source within a defined volume below the detector, for characterizing the directionality, energy, and temporal pattern of signals arriving from a specific point below the ice, for monitoring, with precision and at very low detection thresholds, whatever might be sitting at the location, identified by the Deep Echo survey and the satellite data. The geometry worked both ways. You could design IceCube for cosmic neutrino astronomy, or you could design it for subglacial signal monitoring, and the resulting instrument would look essentially identical. This was not a weakness of Mercer's theory. It was its most elegant and troubling feature. If you wanted to build a classified monitoring system disguised as a legitimate scientific observatory, you could not have designed the cover more perfectly. The early planning documents for IceCube, which Mercer obtained through archival research at several universities that had been part of the original proposal process, showed something that had not been widely remarked upon. Among the early letters of support and institutional endorsements that accompanied the initial funding proposals, there were several from organisations that had no obvious connection to neutrino physics. Research offices within agencies that do not discuss their activities publicly. Planning divisions whose names did not appear in any public directory. Administrative contacts whose institutional affiliations were listed in ways that obscured rather than clarified what organisations they represented. The letters said nothing incriminating. They expressed support for the scientific mission and the value of Antarctic research infrastructure. Anodyne, institutional language of exactly the kind you might expect from any large government agency, endorsing a major scientific project. But they were there, in the files, from the beginning, before construction started, before the site was finalised, before most of the scientific community knew the project was being planned. Mercer asked a colleague who had spent a career studying science policy and government funding mechanisms to look at the documents without telling him what he was looking for. His colleague spent a week reviewing them and then called Mercer with a question. Why, his colleague asked, was the Department of Defense involved in the planning of a particle physics observatory? Mercer did not have an answer that he was ready to share, so he said he did not know. And then he went back to his desk and started thinking about the geometry of the sensor array and what it would mean if the instrument had been designed from the beginning to do two things simultaneously, one of them public, one of them not. Act 8. The dual purpose. To understand why IceCube's dual purpose theory is compelling rather than merely speculative, it helps to think about compartmentalization, the management philosophy used by intelligence and defense organizations when they want to conduct sensitive operations within institutions that are not themselves secret. Compartmentalization means that different people within the same organisation know different things about what the organisation is doing. A scientist at IceCube who spends her career analysing cosmic neutrino data does not need to know that the facility she works in is simultaneously performing a second function. She would not see the secondary data stream. She would not be informed about its existence. She would publish her own research, attend conferences, train graduate students, and do everything that legitimate scientists do, entirely unaware that the monitoring equipment she interacts with every day is also feeding a classified data pipeline that goes somewhere other than her institution's servers. This is not a theoretical capability. Compartmentalized programs embedded within civilian scientific and academic institutions have a documented history going back to the Manhattan Project. During the Cold War, universities, think tanks, and research laboratories throughout the Western world hosted programs whose existence was not disclosed to the majority of people working in those institutions. Some of these programs have since been declassified. Others remain poorly understood decades after the fact. The logistical requirements for embedding a classified monitoring capability within IceCube would not be especially demanding. A secondary data handling system, isolated from the main research network and accessible only to personnel who had been specifically cleared, would leave almost no visible trace in the normal operation of the observatory. The additional sensors needed to perform the subglacial monitoring function could be integrated into the existing string design without being distinguishable from the standard optical modules by anyone who did not know to look for them. The Antarctic location itself provides natural isolation. Physical access is controlled by necessity. Network access is limited by bandwidth. The entire environment is designed, by the requirements of Antarctic logistics, to restrict information flow in ways that would otherwise require elaborate security measures. Most of the scientists working at IceCube in Mercer's framework are exactly what they appear to be. Legitimate researchers doing important work. They are not deceiving anyone. They have not been told anything unusual. They are the genuine face of the operation, the part that is meant to be visible, the part that explains why there is a major research facility at the South Pole at all. And then there is the other part, the part that monitors the anomaly, the part that has been watching continuously since the facility was completed, the part that is looking for something specific, and which, in the winter months of the year that our story reaches its centre, found that the thing it was looking for had changed. Act 9. The signal changes. Dr. Mercer was in his 8th month at the South Pole Station when the anomaly shifted. He had been tracking the directional neutrino cluster for long enough by then that he had established a baseline. The signals arrived irregularly. Sometimes several detections occurred within a single week. Sometimes weeks would pass with nothing. The energy signatures were consistent across events, suggesting the same source, but the temporal pattern was not obviously structured. It looked random, and random in physics is usually a dead end. Random signals are noise, random patterns are coincidence. Random is another word for not interesting. Then, over a period of approximately 12 days in the middle of winter, the pattern changed. The events became more frequent. Not dramatically. The increase was statistically significant but not visually obvious in raw data. You would see it only if you were looking for it and tracking it carefully over time, which Mercer was. The frequency approximately tripled over the 12-day period and then stabilised at that elevated rate. And then something happened that made frequency irrelevant by comparison. The events began to occur at intervals that were not random. The gaps between detections, previously irregular, began to organise themselves. Not perfectly, not so precisely that a casual analysis would catch it, but in Mercer's running statistical models, a structure began to emerge from what had previously looked like noise. The intervals were not uniform. They were not a simple repeating period. They were a sequence with internal structure, with a beginning that was different from a middle that was different from what appeared to be an ending before it started over again. A sequence that repeated, with minor variation, at a scale of approximately 72 hours. Not exactly 72 hours, approximately. As if the source of the signal was keeping a kind of time that was almost but not precisely aligned with the rotation of the Earth. Mercer ran the sequence through every pattern-matching algorithm he had access to. He tested it against known physical phenomena, against known geological processes, against known instrumental artifacts. He tested it against simple mathematical series, prime number sequences, Fibonacci progressions, and more complex mathematical structures. He tested it against communications encoding schemes, against pulse position modulation formats, against every signal structure he could think to look for. Nothing was an exact match. Nothing mapped perfectly onto the sequence he was seeing, but some things were closer than others. The sequence had properties that Mercer described in his notes as resembling, without being identical to, a structured information-bearing signal. Something that would be consistent with communication, if you were willing to use that word very loosely and without committing to what was doing the communicating or to whom. He was not willing to use that word yet. He was a scientist. He needed to be more careful than that. He needed more data and more analysis before he was willing to commit to any interpretation of what he was seeing. But he also needed, urgently, to understand where the signal was going. Because the signal, assuming the dual-purpose theory was correct, was not only being detected by IceCube, it was being monitored, it was being recorded. Somewhere, someone was receiving data on the sequence as it developed, in real time or close to it, and that someone was presumably not doing nothing about it. The question was what they were doing, and whether they had been expecting this moment, and whether whatever was producing the signal had known, for a very long time, that someone was eventually going to be listening. Act 10. The ancient structure. This is the point in the story where the ground shifts beneath you, where the framework you have been building carefully on a foundation of real science and genuine anomalies and documented historical puzzles opens into something much larger and much stranger than a Cold War cover-up or a dual-purpose scientific facility. Because the question that Dr. Mercer eventually had to confront, the question that the data was pointing toward once he stopped asking what the anomaly was and started asking how old it was not a question that any government program, however classified, could fully explain. It was not a question whose answer could be contained by institutional secrecy or bureaucratic compartmentalization. It was a question about time, about how long the thing beneath the ice had been there, about what the world was like when something put it there. The Antarctic ice sheet, in the region where the anomaly is located, is between 3 and 4 kilometres thick. Ice accumulates on the East Antarctic Plateau at an average rate of approximately 6 centimetres per year, though this rate has varied substantially over geological time. At current rates, 3 kilometres of ice represents roughly 50,000 years of accumulation. But current rates are not historical rates. The ice sheet in this region is far older. Drill cores taken at various Antarctic locations have recovered ice that is more than 800,000 years old. The deeper sections of the East Antarctic ice sheet, in some locations, may be significantly older still. The bedrock beneath the anomaly, as revealed by the deep echoseismic data, shows no evidence of any ice-free period during the interval relevant to human civilization. The geological record strongly suggests that this region of Antarctica has been covered by ice, continuously, for somewhere between 15 and 30 million years, possibly longer. If the structure beneath the ice predates the ice sheet, if it was placed or built or formed or deposited in a period when East Antarctica was not glaciated, then it predates the ice by millions of years. It predates the earliest recognizably human ancestors by millions of years. It predates anything that could be called human civilization by an almost incomprehensible margin. The theory that emerged from the small, unofficial group of researchers who eventually became aware of Mercer's work, a group assembled quietly, through careful personal contacts, over the course of nearly 2 years, had 2 versions. One version was the version that had become almost conventional in certain circles of speculative science, the extraterrestrial hypothesis. Something had arrived from somewhere else long ago and been placed beneath what was then a temperate Antarctic landscape before the ice came and sealed it away. The other version was stranger. It required a more fundamental revision of what we think we know about the history of intelligence on Earth. It proposed that the structure was not built by visitors, it was built by residents, by a civilization that had evolved on this planet long before our own lineage emerged. A civilization that had reached a sufficient level of technological development to construct something of this scale, and that had either vanished or transformed into something unrecognizable long before anything we would call human looked up at the stars for the first time. The evidence for this version was obviously extremely limited. It was essentially an argument from inference rather than direct evidence. The structure exists. The structure is very old, therefore something built it. What built it? Nothing we know of. Therefore something we do not know of. A precursor civilization. Mercer's own position on the two theories was characteristically cautious. He did not rule out either. He noted that both required accepting a number of things that were not yet proven. What he was not willing to do, by the time his second winter at the South Pole was ending and he was preparing to leave, was to pretend that nothing was there. The data was what it was. The question was what to do with it. Act 11. The Descent. The drilling mission was not announced publicly. It was not presented in the interagency planning documents that later came to Mercer's attention through sources he never identified as anything more than a routine ice core sampling program, the kind of deep drilling operation that Antarctic researchers conduct regularly for climate science. The logistical requirements of a deep drilling operation provided perfect cover. The personnel roster for the mission was a mix of legitimate glaciologists whose presence explained the cover story, and a smaller group of specialists whose backgrounds and affiliations were less straightforward. Dr. Mercer was included in the team not as a specialist in whatever the non-glaciological aspects of the mission involved, but, or so he was told, as a data analyst. Someone who understood the neutrino detection data and could help the team understand what they might be looking for once they reached the target depth. He was not given a complete briefing. He was given enough to understand that the mission was real, that the decision to conduct it had been made at a level far above the normal channels of Antarctic Science Administration, and that the other non-glaciological members of the team knew things that he did not. The drilling site was established in late October, during the beginning of the Antarctic summer. The hot water drill system was deployed and the work began. Drilling to the depth required, through nearly 4.5 kilometres of ice, and then through the ice-bedrock interface, and then further into the bedrock itself, took 11 days of continuous operation. The crew worked in shifts. The equipment ran without stopping. On the 12th day, the drill reached the anomaly. What happened at that moment was not a dramatic breakthrough in the sense that film and television have conditioned us to expect. The drill did not punch through a ceiling into a vast open space. The transition was subtler. The resistance characteristics of the material being drilled changed. The telemetry from the drill head began returning readings that the glaciologists on the team could not explain. The drill bit was not moving through ice anymore, or through rock. It was moving through something that the instruments characterized, in the dry language of geophysical measurement, as having anomalous acoustic and electromagnetic impedance properties. It took another 3 days to open the access shaft to human entry dimensions. When the shaft was finally ready and the first team member descended, the scientists gathered around the surface opening and watched the video feed from the helmet camera. What they saw on that feed was the reason that a group of people who had spent their professional lives being sceptical of extraordinary claims sat in complete silence for the duration of the descent. The cavity was large, much larger than the drill shaft aperture had suggested it might be. The walls where the light from the helmet camera reached them were smooth. Not the rough, irregular smoothness of natural stone. Smooth in the way that machined or processed surfaces are smooth. A darkness that absorbed light rather than reflecting it. A geometry that was immediately, unmistakably regular. The walls met the floor at angles that a transit or theodolite, had one been available, would have measured as precise. The proportions of the visible space, height, width, the angles of what might have been structural features, were consistent with design rather than with geology. The team descended in pairs over the following 2 days. They mapped the interior using photogrammetry and laser scanning. They took samples. They ran every instrument they had brought with them over every surface they could reach. What they found inside the cavity told a story that none of them were entirely equipped to process. Act 12. The Revelation. The structure was not a building in any sense that would be recognisable to an architect or an archaeologist. It did not have rooms in the conventional sense. It did not have doors, windows, furnishings, or any of the artefacts that normally accompany the presence of intelligent life. It had geometry, an arrangement of surfaces and volumes that followed principles the team could identify: mathematical relationships, proportional systems, spatial logic, without being able to determine the purpose or function of any individual element. What the team eventually concluded, after 2 weeks of careful analysis and several extraordinary arguments conducted in the cramped quarters of the surface support tents, was that the structure was not designed for habitation. It was not a base or a refuge or a home. It was an instrument, a piece of purpose-built technology, operating according to principles they did not yet understand, designed to do something specific. This something specific became clearer when the mission signals analysis specialist, working from data collected by sensors placed throughout the cavity, announced that she had identified the source and direction of the anomalous emissions. The emissions were not radiating outward from the structure, as one might expect if it were transmitting a signal into the surrounding medium. They were being directed inward, focused, concentrated. The structure was acting as a receiver of extraordinary precision and sensitivity. Its geometry, which the team had been trying to interpret as architecture, was in fact the functional design of a detection system. Every surface, every angle, every spatial relationship served a role in focusing, filtering and processing something arriving from outside, something travelling through the earth, through kilometres of ice, bedrock and mantle, from above, from space. The structure was not transmitting to the surface. It had never been transmitting to the surface. The signals that IceCube had been detecting were a secondary emission, a byproduct of the structure's operation, in the same way that a radio receiver produces a small amount of electromagnetic radiation as a consequence of its internal processes. The real signal, the signal the structure was built to detect and process, was arriving from somewhere in deep space and passing through the Earth to reach it. This inverted everything Mercer had assumed. He had been thinking about the anomaly as a source, something producing a signal, perhaps intentionally, perhaps as a byproduct of whatever it was doing. He had been asking who was it communicating with. He had been looking for the recipient of a transmission, but the structure was the recipient. The structure had always been the recipient. It was not sending, it was listening, and it had been listening for a very, very long time. Act 13. What the structure was waiting for. There is a concept in physics and astronomy called a technosignature. It refers to any observable effect that indicates the presence of a technologically capable civilization, either current or historical. Scientists searching for extraterrestrial intelligence have catalogued many possible technosignatures: unusual radio emissions, atmospheric chemical compositions inconsistent with purely biological processes, the modification of a star's light curve by megastructures, artificial signals embedded in cosmic background radiation. What the team found when the signals analysis specialist had completed her work and shared her results was a technosignature of a different kind, not the technosignature of a civilization making itself known, but the technosignature of a civilization watching for the approach of something else, something that was still, at the time of the mission, approaching. The signal the structure was receiving, the signal arriving from deep space, passing through the Earth, being captured and processed by an instrument built millions of years ago by an intelligence we have no other record of, was not random, it was structured. It was, in the judgment of the signals analysis specialist, an artifact signal, something produced by an intelligent source at astronomical distance, travelling across space at the speed of light, directed at a receiver that the source had known was here. The implications of this took time to land fully. The structure had been built by something. That something had known about a signal that was coming from deep space. That something had built a receiver precisely calibrated to detect that specific signal when it arrived. And that something had left the receiver operating, unattended, for a period of time that might be measured in the tens of millions of years, waiting for the signal to arrive. The distance implied by the signal's travel time, if it could be determined, would say something about how far away the source was. The signals analysis specialist worked on this question for several days. Her conclusion was tentative, dependent on assumptions that could not be independently verified, and deeply unsettling. Based on the characteristics of the signal as she could measure them, and based on what she could determine about when the structure had been built relative to when the ice sheet had formed above it, she believed the signal had been travelling for a period consistent with having originated in another galaxy. Not nearby, by cosmic standards. Not from a star that our telescopes could easily see or name. From somewhere that light had been crossing the void toward us since before the ancestors of the dinosaurs walked the Earth. Something out there, at distances that render human timescales meaningless, had known about this planet, had known about the structure here, had sent a signal that would take an unimaginable time to arrive, and had sent it anyway, confident that something would be here to receive it when it came. The question that kept the team awake during the remaining days of the mission was the most important question that any human being had ever been in a position to ask. What was in the signal? They did not know yet. The structure was receiving it, processing it, doing whatever it was built to do with the information it was extracting. But they did not have the tools or the knowledge to read what the structure was reading. They could detect the signal. They could characterize it. They could not understand it. Not yet. Act 14. Why governments chose silence. The question of why governments that became aware of the anomaly chose to suppress rather than reveal the information is, in many ways, the most human part of this entire story. The structure is alien in the true sense, outside of human experience, beyond easy comprehension. But the decision to classify, to conceal, to build an observatory rather than a press conference, that decision is entirely human, and its logic is not difficult to follow once you stop expecting it to be sinister. Consider what a government, in the 1970s, would have faced if it had made the deep echo findings public. An announcement that geophysicists had discovered a geometric anomaly beneath the Antarctic ice that appeared to be artificial in origin, that it appeared to be producing electromagnetic signals, that it appeared to predate the Antarctic ice sheet by millions of years, that no human civilization or known natural process could explain it. This announcement would have produced one of two outcomes. Either it would have been widely disbelieved, generating ridicule rather than serious scientific attention, and damaging the credibility of everyone associated with it. Or it would have been believed, generating precisely the kind of civilizational crisis that institutions exist to manage and contain. Panic is not a metaphor in this scenario. The genuine discovery of evidence that non-human intelligence had been operating on this planet millions of years before our species emerged, and that something from deep space had sent a signal to a receiver built by that non-human intelligence, and that the signal was still arriving. This is information that most governance structures were not designed to handle, so instead they managed it. They set up a monitoring program inside a legitimate scientific institution. They watched the anomaly continuously without drawing attention to why they were watching it. They waited to see what developed, and when the signal began changing, when it became more structured, more frequent, more clearly something rather than the ambiguous something it had always been, they moved, quietly, without announcing what they had found. Without convening a global conversation about the implications, they sent a small team with a cover story and they went to look. Is this the right response? Is silence, in the face of the most extraordinary discovery in human history, the appropriate choice? Mercer did not think so. He had spent more than a year by the time the mission concluded believing that the concealment was the scandal, that the data deserved to be in the scientific commons, that the decision being made about what humanity would and would not know about its own planet was a decision that should not be made by a small group of officials in consultation with their counterparts in other governments. But he also understood, more than he had before the descent into the cavity, why someone might look at the signal arriving from somewhere impossibly far away, directed at a receiver built by something that no longer existed, and decide that the public conversation could wait. That perhaps the thing to do first was to understand what the message said, to have some idea of what was coming before everyone knew that something was. He did not agree with that reasoning, but he understood it. Act 15. The activation event. The change in signal frequency that had drawn Mercer's attention, that had precipitated the shift from passive monitoring to active investigation, was not, as it turned out, a new development. It was the latest in a series of similar increases that the classified monitoring program had tracked over the decades since IceCube became operational. The signals had been growing more frequent, more structured, and more energetic over a period spanning approximately 40 years. Not linearly, not on a smooth curve, in steps. Each step up lasted for a period ranging from weeks to months, after which the signal would stabilise at its new, higher level before the next increase. The overall trend was clear. Whatever was sending the signal was getting closer, or the signal was getting stronger as it approached, or something about the relationship between the source and the receiver was changing in a way that produced more signal at this end of the link. The classified monitoring program had anticipated, based on the trajectory of signal increases, that a threshold of some kind would be reached within approximately 2 decades, a threshold at which the signal would change in character, not merely in intensity, a threshold at which the structure's processing would shift from what they had been observing to something different, a threshold that might represent, and here the language used in the classified documents became careful to the point of opacity, an event of significance. IceCube had been built in part to watch for that threshold, to detect the event with the precision that a 5,000 sensor array spread through a cubic kilometre of pristine ice could provide, to give whoever was monitoring the program adequate notice of whatever the transition represented. Adequate notice to do what, exactly, was a question the documents did not answer. Mercer suspected this was because the people who had built the monitoring program did not know what they were going to do when the threshold arrived. They had been buying time, collecting data, hoping that by the time the moment came, they would understand enough to have some idea of how to respond. They did not understand enough yet. The team that descended into the cavity came back with an extraordinary amount of data, not nearly enough knowledge to interpret it. The structure was operational. The signal was arriving. The processing was occurring. Whatever the structure was doing with the information it was extracting from the incoming signal was happening in materials and at scales and through processes that the team's instruments could detect but not decipher. The threshold had not been reached yet, but it was closer, and when it was reached, when the signal completed whatever transition it was building toward, the structure would do something. Something that the people watching it, for all their decades of preparation, did not yet know how to predict. Epilogue. The South Pole, continuing years have passed since the mission that Mercer was part of. The South Pole Station continues to operate. New personnel cycle through every summer. New graduate students arrive to work on their dissertations. New papers are published in new journals. The IceCube collaboration announces results at conferences and posts preprints to physics archives, and researchers around the world download them and argue about the data in seminar rooms and coffee shops. None of them, with almost no exceptions, know anything about the second data stream, the monitoring that runs beneath the legitimate research. the quiet watching that has been the institution's other purpose from the beginning. Mercer left the South Pole after his third consecutive winter and took a position at a university that keeps him several continents away from Antarctica most of the year. He does not speak publicly about what he found. He does not publish papers about the anomaly or the structure or the signal. He does his regular research. He teaches his classes. He answers his emails. And every few weeks, through channels he will not describe to anyone he has not worked closely with for years, he receives an update on the signal's status, on whether the frequency has changed again, on whether the threshold indicators have moved, on whether the moment is closer or further or the same as it was before. The last update he received before our account of his story ends said that the signal was stable, that the threshold indicators had not changed significantly in the preceding period, that the structure beneath the ice was operating normally, whatever normally meant for an instrument of its age and origin, that there was nothing yet that required an escalated response. He read that update sitting at his desk in the early evening, with snow falling outside his office window, 5,000 miles from the South Pole. He read it the way you read something you have been reading variations of for years, not with alarm, not with relief, with the careful, trained attention of someone who has learned to watch for specific things in familiar data. He's watching for the moment when stable becomes unstable, when the signal shifts again, when the threshold indicators move in the direction that everyone who knows about them has been hoping they would not move. He hopes that when that moment comes, the people with the authority to decide what to do about it will have figured out by then what to do. He is not confident they have. He is not confident they will. He has spent enough time in the rooms where those decisions are made to have lost most of his faith in the adequacy of the process. But he watches, because watching is what he can do, because the data will tell him, before anything else does, when everything is about to change, and because knowing, even knowing something you cannot act on and cannot share, is better than the alternative. The detectors do not sleep. The sensors suspended in their cubic kilometre of ancient ice keep their vigil through every polar night and every polar day. Most of what they find is the universe speaking to itself in the language of particles, the constant ordinary traffic of neutrinos pouring through the planet from every direction, carrying messages from stars and galaxies and events so remote that the light from them will never reach human eyes. But some of what they find is something else, something that comes from a specific place, that has been coming from that specific place for longer than our species has had language to describe what finding means, something that is still arriving, still being received, still being processed by a receiver that was built to wait and has been waiting through every age of ice and before. The next transmission has not arrived yet, the one that everyone fears, but the sensors are listening, and the ice keeps its secrets, as it always has, beneath the unbroken dark of the polar winter, where the only sound is the silence of something very old and very patient, waiting for a signal it has always known was coming. Before we begin, if you're enjoying this content, please consider using your hype points on this video. It helps the channel more than you possibly know. If you're listening on Spotify, leaving a review also helps out so much. And if you'd like, comment what time it is for you and where in the world you're listening from. We absolutely love seeing where everyone is tuning in from across the globe. And of course, If you enjoy the content, please consider subscribing. Now, let's dive into tonight's story. The Smithsonian's Darkest Secrets. What if the bones were too big to explain? Picture this: a team of excavators in Ohio, 1879, uncovering a burial mound. The dig proceeds normally until they reach the central chamber. There, arranged in ceremonial position, lies a skeleton. But something is wrong. The femur is too long. The skull is too large. The ribs extend far beyond normal human proportions. The team measures carefully. They document everything. They contact the Smithsonian Institution, America's premier scientific authority. Representatives arrive. They examine the remains. They carefully pack everything into crates. The crates are loaded onto wagons, then trains. They disappear into the vaults of the nation's most trusted museum. And then, according to some researchers, those bones are never seen again. This is the central allegation that has haunted the Smithsonian Institution for over a century. Not a single dramatic cover-up, but a pattern. A systematic removal of evidence that challenges our understanding of the past. Artifacts that don't fit the established narrative, quietly set aside. Discoveries that raise uncomfortable questions, lost in bureaucratic shadows. The Smithsonian Institution stands as the world's largest museum and research complex. 19 museums, 9 research centres, 140 million artifacts and specimens. It defines American history for generations of schoolchildren. It shapes our collective memory of who we were and how we came to be. Millions walk through its halls each year. They stand before dinosaur skeletons and moon rocks. They examine the Wright brothers' flyer and the Star-Spangled Banner. They trust that what they see represents the complete story of human achievement and natural history. But what if some discoveries never made it to the display cases? What if the story we've been told is incomplete? Not because of malicious conspiracy, but because institutions, like people, sometimes choose comfort over confrontation. Tonight, we examine the allegations. We follow the paper trails. We explore the missing artifacts, the vanished records, and the persistent claims that history has been edited before reaching our eyes. We'll hear from believers and skeptics. We'll examine evidence and counter-evidence. We'll ask uncomfortable questions about the institutions we trust to preserve truth. This is the story of the Smithsonian's Darkest Secrets, a story that begins not with malice, but with money, not with conspiracy, but with a gift that would change American science forever. Chapter 1: The Rise of an Authority. The Smithsonian Institution was born from the will of an Englishman who never visited America. James Smithson, a British scientist and mineralogist, died in 1829 in Genoa, Italy. His life had been devoted to scientific inquiry. He published 27 papers on chemistry and geology. He travelled throughout Europe collecting mineral specimens. He was a Fellow of the Royal Society, one of the most prestigious scientific organisations in the world. But Smithson harboured a resentment. He was the illegitimate son of the Duke of Northumberland. Though brilliant, he could never inherit his father's title or estate. British society, for all its scientific advancement, still judged men by birth rather than merit. Perhaps that's why his will contained such an extraordinary clause. If his nephew, Henry, James Hungerford, died without heirs, Smithson's entire estate would go to the United States government. The purpose: to found at Washington, under the name of the Smithsonian Institution, an establishment for the increase and diffusion of knowledge. Why America? Smithson never explained. He never visited the country. He had no known American connections. But he saw in the young republic something Britain lacked: the promise of meritocracy, a place where knowledge mattered more than lineage. The nephew died childless in 1835. The inheritance, worth over $500,000 in gold sovereigns, became available. This was an enormous sum, equivalent to well over $10 million today. But Congress hesitated. Should the United States accept a gift from a foreign citizen? What strings might be attached? What would this institution actually do? Debate raged for nearly a decade. Some wanted a national university. Others proposed an observatory, a library, or a museum. Former President John Quincy Adams, then serving in Congress, championed the cause. He argued that accepting Smithson's gift was a matter of national honour. Finally, in 1846, President James Polk signed the act establishing the Smithsonian Institution. The legislation was deliberately vague about the institution's specific mission. It would promote knowledge. The details would evolve. Joseph Henry, a renowned physicist, became the first secretary. He envisioned the Smithsonian primarily as a research institution, not a museum. He wanted to fund original scientific investigation and publish findings. He was less interested in collecting objects, but the building itself suggested otherwise. Architect James Renwick designed a castle in red sandstone, with towers and crenellations evoking medieval fortresses of knowledge. It looked like a place to house treasures, not just conduct research. From the beginning, the Smithsonian faced a fundamental tension. Would it be a research institute or a museum? Would it generate new knowledge or preserve existing discoveries? The answer became both. And in trying to be both, it accumulated power. The timing was perfect. America in the mid-1800s was experiencing an explosion of archaeological discoveries. As the frontier expanded westward, as railroads cut through previously unmapped territory, as settlers ploughed fields and built foundations, they encountered evidence of ancient habitation. Burial mounds dotted the landscape from the Great Lakes to the Gulf of Mexico. Earthworks of staggering scale emerged from forests being cleared for farmland. Artifacts surfaced. Copper tools, shell beads, stone carvings, ceramic vessels. Who made these? The question consumed popular imagination. Native American tribes had oral histories about some sites, but the sheer scale of certain earthworks seemed beyond what small tribal groups could accomplish. Also, white Americans reasoned bringing their own biases to interpretation. The Smithsonian positioned itself as the authority on these questions. It dispatched researchers across the expanding nation. It collected specimens by the thousands. It established protocols for excavation and preservation. It decided what was scientifically significant and what was mere curiosity. Cyrus Thomas, employed by the Smithsonian's Bureau of Ethnology, beginning in 1882, led extensive surveys of ancient mounds throughout the eastern United States. His mission was clear: determine who built the earthworks that puzzled settlers and scientists alike. Thomas was methodical. He visited hundreds of sites. He supervised excavations. He catalogued thousands of artifacts. He reviewed every account, every theory, every wild speculation about ancient builders. His conclusion, published in 1894 in a massive report, became institutional orthodoxy. The mounds were built by ancestors of contemporary Native American tribes, not by a separate vanished race. There were no lost civilizations, no mysterious mound builders. The engineering and labour were entirely within the capabilities of indigenous peoples. This was actually progressive for its time. It countered racist theories that Native Americans were too primitive to have built such structures. It acknowledged indigenous achievement and continuity. But it also established a pattern. The Smithsonian would define the boundaries of acceptable history. It would determine what theories deserved consideration and what theories were pseudoscience. It would decide which artifacts merited preservation and which could be discarded as unimportant. And with authority comes power. The power to decide what is remembered, the power to choose what is forgotten, the power to shape collective memory. By the early 20th century, the Smithsonian had become the central repository for American archaeology. If you discovered something significant, you contacted the Smithsonian. If you wanted funding for excavation, you needed Smithsonian approval. If you hoped to publish findings in respected journals, you needed Smithsonian endorsement. This centralization had benefits. It prevented duplication of effort. It raised standards for archaeological practice. It protected sites from amateur looters. But it also created vulnerability. A single institution now controlled access to much of the physical evidence of America's past. And if that institution had blind spots, biases, or reasons to avoid certain questions, there were few checks on its authority. The conspiracy theories that would haunt the institution for the next century were already taking root. Because as the Smithsonian accumulated artefacts by the tens of thousands, then hundreds of thousands, questions arose that have never been satisfactorily answered. What happened to everything they collected? Where did it all go? How were decisions made about what to study, what to display, what to store, and what to quietly remove from consideration? And if something challenged their conclusions, would they have any incentive to share it? Or would the easier path be to set it aside, catalogue it vaguely, and let it disappear into the vast collections where few would ever look? These weren't unreasonable questions then. They aren't unreasonable now. Chapter 2. The Giant Skeleton Claims. The newspaper accounts are extensive and surprisingly consistent. The New York Times, November 10th, 1880, page 5. A giant's bones. The body of a man 11 feet 4 inches high discovered near Middletown, Ohio. The San Diego Union, August 5th, 1877. Front page. Remains of giants unearthed. Skeletons of extraordinary size found in California burial mounds. The Indianapolis News, November 10th, 1875. Remains of gigantic size disinterred near Greencastle. The skeleton measured 8 feet from crown to heel. The Worthington, Advance, Minnesota, May 10th, 1888. A giant's bones unearthed. Remains measuring 9 feet in length found during excavation of Indian mound. Dozens, perhaps hundreds, of similar reports appear in newspapers across America between 1850 and 1920. They describe the discovery of human skeletons measuring 7, 8, 9, even 10 feet tall, often found in burial mounds, frequently accompanied by copper tools, shell beads, and other artifacts suggesting ceremonial burial. The reports follow a remarkably consistent pattern. Local excavators, often farmers or construction workers, make a discovery while digging. They recognise the bones as human but note unusual size. They contact local authorities or newspapers. The story is published. Scientists or museum representatives are contacted. The remains are measured, documented and packed for transportation to institutions like the Smithsonian for further study. And then, according to conspiracy theorists, the trail goes cold. Researchers today who try to locate these skeletons in Smithsonian collections claim they cannot find them. The catalogue numbers don't match existing records. The accession documents are incomplete or missing. The specimens have been deaccessioned or lost in transfer, or simply cannot be located despite extensive searching. Let's examine a specific case in detail. In May of 1897, the Times of London reported on excavations in Lovelock Cave, Nevada. The site yielded numerous artifacts and skeletal remains. According to reports, some of the skeletons measured significantly above normal human height ranges. The tallest supposedly measured 8 feet, 4 inches. The excavation was supervised by James Hart Mercer, an archaeologist who worked with the Smithsonian. His field notes, which still exist in archives, describe skeletal material of unusual dimensions. He arranged for the remains to be shipped to Washington for analysis. Modern researchers seeking these specific bones have been unable to locate them in Smithsonian collections. The institution acknowledges receiving materials from Lovelock Cave, but the catalogue descriptions don't match Mercer's field notes. Heights listed are within normal ranges. The unusually large specimens are absent. What happened? 3 possibilities. First, the measurements were wrong. Mercer was working in difficult conditions. Bones were fragmentary. He might have misassembled remains or measured incorrectly. Second, the bones were misidentified. Large animal bones were mistaken for human remains. This happened frequently in early archaeology. Third, the bones existed as described but have since been lost, destroyed, or deliberately removed from the collection. The conspiracy theory embraces the third explanation, but the first 2 are more probable, and yet the pattern repeats across dozens of cases. The most famous allegation involves a Supreme Court case that never actually happened. In 2005, a story began circulating online. It claimed the Smithsonian Institution had been sued in federal court for destroying evidence of giant skeletons. The supposed lawsuit was filed by the American Institution of Alternative Archaeology. The court allegedly ruled in favour of the plaintiffs, ordering the Smithsonian to release classified documents proving the institution had destroyed tens of thousands of giant human remains in the early 1900s. The story was elaborate. It included fake quotes from Smithsonian officials admitting the destruction. It referenced specific case numbers and court dates. It spread rapidly through conspiracy theory websites and social media. Except none of this happened. There is no such court case, no ruling, no American Institution of Alternative Archaeology. The entire story was a fabrication, created by a satirical website and then taken seriously by people who wanted to believe it. When confronted with the hoax, true believers didn't abandon the theory. They claimed the debunking itself was part of the cover-up. The fact that no evidence existed for the lawsuit proved how powerful the conspiracy was. But the fabricated lawsuit built on a foundation of genuine mystery. Because those 19th century newspaper reports are real, they exist in archives. You can read them yourself in digitised historical newspaper collections. So what explains them? The official position is straightforward and, honestly, pretty convincing. Early American archaeology was chaotic and unscientific. Professional archaeology didn't really exist as a discipline. Most excavations were conducted by amateurs. Measurements were inaccurate, standards for documentation didn't exist. Giants were actually normal skeletons that appeared larger due to several factors. Soil displacement and geological pressure could spread bones apart, making them seem larger than life size. Decomposition and mineralization could cause bones to expand. Enthusiastic local boosters exaggerated findings to attract attention and tourists. Newspapers of that era printed sensational stories without rigorous verification. If a farmer claimed he found giant bones, the local paper might print it without investigation. Some cases have clear, documented explanations. A giant skeleton discovered in New York in 1871 turned out to be a mastodon. The initial report described it as human before expert examination revealed the truth. The mysterious 7-foot skull found in Missouri in 1894 was from a cave bear. The finder genuinely believed it was human. Only later analysis corrected the identification. The Cardiff Giant, perhaps the most famous giant of the era, was an outright hoax. A 10-foot-tall stone figure uncovered in New York in 1869. Thousands paid to see it. Scientists from Yale examined it. Some declared it proof of ancient giants mentioned in the Bible. It was eventually revealed as a carved gypsum statue, created by an atheist named George Hull specifically to mock biblical literalism. But not before making its creator thousands of dollars and fooling numerous educated people. If educated scientists could be fooled by an obvious fake carved from soft stone, how much easier would it be for amateurs to misidentify unusual animal bones? But not all reports fit this explanation. Some described skeletons excavated by trained observers. Some included multiple independent witnesses. Some were documented by reputable scientists of the era who should have known the difference between human and animal remains. In 1891, Professor Thomas Wilson of the Smithsonian's Department of Prehistoric Anthropology wrote about excavations in Ohio. His report mentioned human remains of extraordinary stature found in association with clearly human artifacts. Wilson was a trained anthropologist. He wasn't likely to confuse a mastodon with a human. What happened to the remains he described? They should be in the collection. The catalogue numbers exist, but the specimens cannot be found. The conspiracy theory asks a simple question. If even a handful of these reports were accurate, if humans significantly taller than normal once lived in North America, what happened to the evidence? And the answer conspiracy theorists arrive at is equally simple. The Smithsonian made it disappear, not because of malice, not because of some grand plan, but because these remains didn't fit the accepted narrative of human development. They raised questions that couldn't be easily answered. They complicated the story the institution was tasked with telling, so they were set aside, catalogued vaguely, stored in boxes that nobody opened, and over decades, They were simply lost in the vast holdings of an ever-growing collection. Is this what happened? We can't know for certain, but the gaps in the record remain, and gaps, once noticed, are hard to ignore. Chapter 3. Missing Artifacts and Vanished Records. In 1991, a researcher named Vine Deloria Jr. published a book called Red Earth, White Lies, Native Americans and the Myth of Scientific Fact. Deloria was a Standing Rock Sioux, author, theologian, historian and activist. He held degrees from Iowa State, the Lutheran School of Theology, and a law degree from the University of Colorado. He wasn't a fringe conspiracy theorist. He was a serious scholar with legitimate credentials. His book challenged conventional archaeology on multiple fronts. But one chapter focused specifically on the Smithsonian Institution. He claimed the institution had a pattern of losing or discarding artifacts that didn't fit accepted timelines for human habitation in the Americas. Deloria cited specific examples. Stone tools found in geological layers at Hueyatlaco, Mexico, supposedly too old for human presence in the Americas. The tools existed, the excavation was professional, but the implications were so disruptive to accepted chronology that the findings were marginalized. Carved figurines from Nampa, Idaho, depicting extinct animals that humans weren't supposed to have encountered. The figurines were genuine artifacts, but they were found in geological contexts that suggested impossible antiquity. Rather than forcing reconsideration of timelines, they were labelled as somehow displaced or contaminated. Metal objects from cultures that supposedly hadn't developed metallurgy. Copper axes, bronze implements, iron tools found in contexts that predated when these technologies were supposed to exist in the Americas. Deloria's claim wasn't that the Smithsonian was maliciously destroying evidence. His argument was more subtle and in some ways more damning. He suggested the institution had become so invested in a particular narrative of American prehistory that it couldn't accommodate evidence that challenged that narrative. Artifacts that fit the story were carefully preserved, studied and displayed. Artifacts that didn't fit were treated with skepticism, catalogued vaguely, stored in less accessible locations and gradually forgotten. He cited excavation reports that referenced artifacts no longer in collections, catalogue numbers that led nowhere, requests to examine specimens that were denied or redirected to different materials entirely. Other researchers echoed these concerns. They pointed to early 20th century expedition reports that described remarkable finds that should have revolutionized understanding of ancient America. But the artifacts described in those reports couldn't be located in current collections. An 1897 expedition to Tennessee Mounds, led by Smithsonian archaeologists, documented in their field report the discovery of unusual metallurgical specimens showing evidence of smelting techniques not previously documented in Eastern Woodlands cultures. The catalogue, numbers assigned to these items, still exist in the archives, but the items themselves cannot be found. A 1913 field notebook from an Arkansas excavation describes carved stones bearing undeciphered symbols suggesting organised writing system. The notebook is carefully preserved in the Smithsonian archives. Researchers can read the detailed descriptions, view the hand-drawn sketches of the symbols, but the stones themselves are not in the collection. An 1884 letter from a Smithsonian curator to a colleague mentions receiving skeletal material of unusual proportions, requiring further anatomical study. No follow-up correspondence exists. No study was published. The specimens are not listed in current catalogues. Are these innocent casualties of time and institutional change? Almost certainly some are. The Smithsonian has experienced fires, floods and relocations. Materials have been damaged or destroyed through accident rather than intent. Early cataloguing systems were inconsistent. Items were sometimes accessioned under descriptions that don't match current search terms. Storage facilities have changed. Collections have been reorganised multiple times. All of this creates natural gaps in institutional memory. But the pattern of gaps surrounding specifically anomalous artefacts is striking. Items that would have been controversial, that challenged accepted theories, seem disproportionately likely to be among the lost. The Smithsonian's response has been consistent. Early archaeological practice was poor. Documentation was incomplete. Many early excavations were conducted by amateurs who made claims without proper evidence. Items were sometimes accessioned based on donor descriptions that later proved inaccurate or exaggerated. When the institution couldn't verify the provenance or authenticity of an artifact, it was deaccessioned. This wasn't conspiracy. It was responsible museum practice. Museums cannot keep everything. Decisions must be made about what merits preservation and what doesn't. But critics point out an uncomfortable reality. Who decides what can be verified? What standards of evidence are applied? And if an artifact challenges fundamental assumptions about the past, might there be unconscious bias in how rigorously it's examined? If a stone arrowhead is found and donated, it's probably accepted with minimal scrutiny. It fits what we expect. But if a complex mechanism is found in an ancient context, might it face higher standards of proof? Might researchers look harder for reasons to dismiss it? This is the insidious nature of confirmation bias. It's not deliberate dishonesty. It's the human tendency to accept evidence that confirms existing beliefs and scrutinize evidence that challenges them. The deeper researchers dig into Smithsonian records, the more gaps they find. And these aren't just random gaps. They cluster around specific types of claims, evidence of human presence in the America's earlier than accepted timelines, evidence of technological sophistication in cultures deemed primitive, evidence of anatomical variation in ancient human populations, evidence of cultural achievements that challenge narratives of linear progress. Each individual gap might have an innocent explanation, but the pattern of gaps creates suspicion, and once that suspicion exists, absence of evidence becomes its own kind of proof. If the Smithsonian isn't hiding anything, why can't they produce the artifacts described in their own historical records? Why aren't the specimens mentioned in century-old expedition reports available for modern analysis with advanced techniques? The official answer remains: they probably never existed as described, or they weren't what people thought they were, or they were lost through ordinary institutional processes over more than a century of operations. But conspiracy theorists hear a different message. They did exist. They were exactly what people thought, and now they're conveniently gone. Chapter 4. Advanced Ancient Knowledge. The stone walls at Sacsayhuaman in Peru fit together so precisely that you cannot slide a knife blade between them. Some blocks weigh over 200 tons. They were somehow transported miles from quarries, lifted into position, and cut with such accuracy that no mortar was needed. The Great Pyramid of Giza was the tallest human-made structure on Earth for over 3,500 years. Its base is level to within less than an inch. Its sides align almost perfectly with true north. The interior passages demonstrate sophisticated understanding of mathematics and engineering. The Antikythera mechanism, recovered from a Roman-era shipwreck off Greece in 1901, contains gear systems and astronomical calculations that wouldn't appear again in European technology for over a millennium. It predicted solar eclipses, tracked planetary movements, and calculated the Olympic Games cycle. Ancient civilizations achieved things that challenge our understanding of their capabilities. This is not conspiracy theory. This is established fact, acknowledged by mainstream archaeology. But the question becomes, how much more advanced were they than we acknowledge? And more importantly, what evidence of that advancement has been minimized, overlooked, or deliberately ignored because it doesn't fit comfortable narratives of gradual technological progress? Some conspiracy theorists claim the Smithsonian has actively downplayed evidence of technological sophistication in ancient cultures, particularly in the Americas. The allegation isn't that ancient people had computers or aircraft. It's more subtle and, honestly, more plausible. The claim is that evidence of advanced knowledge, precision engineering, and sophisticated understanding of mathematics, astronomy, and metallurgy has been systematically minimized to maintain a narrative of gradual, linear progress from primitive to advanced. The favorite model in mainstream archaeology is evolutionary. Hunter-gatherers become farmers. Farmers build villages. Villages become cities. Cities develop writing. Writing enables mathematics. Mathematics enables engineering. Each step follows predictably, logically, from the last. It's a comforting narrative. It suggests progress is inevitable. It implies our current civilization is the pinnacle of human achievement. But what if the pattern wasn't so linear? What if ancient people understood principles we think they couldn't have grasped? What if technological knowledge was sometimes lost rather than continuously accumulated? Conspiracy theorists point to specific examples that trouble mainstream explanations. The Piri-Reis map of 1513 shows coastal details of South America with remarkable accuracy. More controversially, it appears to show coastline features of Antarctica that wouldn't be mapped by modern explorers until centuries later. The map's creator, Ottoman Admiral Piri-Reis, claimed he based it on much older source maps, some dating to the time of Alexander the Great. How did ancient cartographers map Antarctica? The conventional answer: they didn't. The map shows South America's coast, and the Antarctic portion is misidentified coastline or pure fabrication. But the accuracy of other portions of the map makes this explanation less satisfying. The Baghdad Battery, discovered in Iraq in 1936, consists of a clay jar containing a copper cylinder and an iron rod. When filled with acidic liquid, it generates small electric current. It dates to approximately 2,000 years ago. Was this actually a battery, or just a scroll container that happens to generate current as a side effect? Mainstream archaeology favours the latter, but experimental archaeology has shown these devices could effectively electroplate objects. Did ancient metallurgists understand principles of electrochemistry? Precision-drilled holes in granite at ancient Egyptian sites show characteristics that modern engineers associate with high-speed drilling equipment. The holes are perfectly circular, maintain consistent diameter through hard stone, and show spiral grooves suggesting rapid rotation. Conventional archaeology argues they were made with copper tools and sand abrasive, through patient application of rotational pressure. But experimental attempts to replicate these holes using proposed ancient methods have struggled to match the precision and speed suggested by the archaeological evidence. The Smithsonian's position on these artifacts is carefully calibrated. The institution acknowledges the sophistication. It marvels at ancient ingenuity. Its exhibits celebrate the achievements of past civilizations. But it argues these achievements are explainable within the bounds of known, ancient technology and knowledge. The Piri-Reis map drew on older sources, but those sources were medieval or classical, not impossibly ancient. The Baghdad Battery might have been used for electroplating, but this doesn't prove systematic understanding of electricity. The Egyptian drillings were accomplished through techniques we haven't fully rediscovered, but that doesn't mean they required advanced technology. The conspiracy theorist argues, but what if we're underestimating these civilizations not because of evidence, but because we're committed to a particular narrative of human development? What if our models of technological progress are oversimplified? What if we've set the bar for ancient achievement artificially low, then use that lowered bar to dismiss evidence that exceeds it? Consider a specific case that illustrates this tension. In 1964, geologist Virginia Steen McIntyre was part of a team dating artifacts from Hueyatlaco, Mexico. They used multiple dating methods: uranium series, tephrohydration, and stratigraphic analysis. All methods consistently indicated the tools were over 250,000 years old. This created an obvious problem. Anatomically, modern humans weren't supposed to exist 250,000 years ago, let alone in the Americas. The accepted timeline for human migration to the Americas was roughly 12,000 to 15,000 years ago. Steen McIntyre's findings, if accurate, would demolish that timeline. They would require complete reconsideration of human evolution and migration patterns. Her findings were rejected. Papers were refused publication. Colleagues distanced themselves. Her career suffered significantly. She later claimed she experienced direct institutional pressure from organizations including the Smithsonian. Pressure to reinterpret the data. Suggestions that her dating methods must be flawed. Implications that publishing such findings would damage her professional reputation. Was this conspiracy? Or was it simply the scientific process working as intended, subjecting extraordinary claims to extraordinary scrutiny? The line between healthy skepticism and close-minded orthodoxy is extremely thin, and institutions like the Smithsonian which help define where that line falls, hold enormous power over what becomes accepted knowledge. Steen McIntyre's work remains controversial. Some researchers argue her dating methods were sound, and archaeology needs to reconsider timelines. Others maintain the dates must be incorrect because they conflict with overwhelming evidence from other fields. But notice what happened. The evidence wasn't destroyed, it wasn't hidden, it was questioned, criticised, and largely dismissed. The artefacts still exist, but they've been relegated to anomaly status. They don't appear in textbooks. They don't inform the standard narrative taught to students. This is a subtler form of information control than physical destruction of artefacts. It's the power to decide what evidence matters, what deserves attention, what merits inclusion in the official story. And that power, exercised over decades by institutions like the Smithsonian, shapes our entire understanding of the past. Chapter 5: Indigenous History and Narrative Control. The Mound Builder myth was one of 19th century America's most destructive historical frauds, and one with lasting consequences. It went like this. The impressive earthworks and burial mounds throughout the eastern United States were too sophisticated, too large, too precisely engineered to have been built by Native Americans. They must have been constructed by a separate, vanished race of mound builders who possessed advanced knowledge and civilization. These mysterious mound builders were variously theorized to be lost tribes of Israel who migrated to the Americas, wandering Europeans or Phoenicians who reached North America in antiquity, survivors from Atlantis or other legendary civilizations, an advanced race that was later conquered or absorbed by primitive native tribes. This wasn't just academic speculation. It served a direct political purpose. If Native Americans hadn't built the mounds, they had no special historical claim to the lands that contained them. They were recent arrivals, just like European colonists. Therefore, westward expansion could proceed with reduced moral complication. If indigenous peoples weren't connected to the ancient civilizations that once flourished here, their displacement was less troubling. The myth was widespread, believed by prominent Americans, including Thomas Jefferson, who wrote about it extensively. It appeared in newspapers, textbooks, and scientific journals. It shaped policy and public opinion. The Smithsonian's Cyrus Thomas demolished this myth with his 1894 report on the mound explorations of the Bureau of Ethnology. He proved conclusively through careful excavation and analysis that Native American ancestors built the mounds. The engineering was entirely within the capabilities of indigenous peoples. The cultural continuity was clear. This was real scholarship, opposing racist pseudo-history. Thomas deserves credit for applying scientific rigour to politically charged questions. But some researchers claim the Smithsonian went too far in the opposite direction. In the effort to combat the mound builder myth, they argue, the institution minimised the genuine complexity and sophistication of pre-Columbian North American civilizations. The conspiracy theory goes like this. Acknowledging truly advanced indigenous civilizations would raise uncomfortable questions. It would force recognition of what was lost during European colonization. It would complicate the narrative of European civilization bringing progress and enlightenment to a primitive continent. It would create moral and legal complications regarding land rights and historical injustice. So evidence of that complexity and advancement, when it appeared, was acknowledged but not emphasized. It was studied but not celebrated. It was preserved but not prominently displayed. Consider Cahokia, the ancient city near modern St. Louis, Missouri. At its peak around the year 1100, Cahokia was larger than London. Its population exceeded 10,000, possibly reaching 20,000. Its central plaza covered 40 acres. Monk's Mound, the largest earthwork, rose 100 feet high and covered 14 acres at its base. It contained more material than the Great Pyramid of Giza. This was an urban civilization. It had sophisticated agriculture supporting large populations, extensive trade networks reaching from the Great Lakes to the Gulf of Mexico, complex social hierarchies and specialized labor, advanced astronomical knowledge demonstrated by structures precisely aligned with solstices and equinoxes. Cahokia was not a village, it was a metropolis, and it existed at the same time as medieval European cities, yet how many Americans learned about Cahokia in school? For most people educated before the late 20th century, the answer is none. It simply wasn't taught. It wasn't part of the standard curriculum. It didn't appear in history textbooks alongside accounts of European medieval cities. Why not? The evidence was there. Archaeologists knew about Cahokia. The Smithsonian had extensive materials from the site. But Cahokia didn't fit the narrative. It complicated the story of indigenous peoples as primarily hunter-gatherer societies. It suggested pre-Columbian civilization in North America was far more advanced than commonly believed. The city collapsed mysteriously around 1300, before European contact. Climate change, resource depletion, social upheaval, possibly epidemic disease. The reasons remain debated. But its very existence challenged comfortable assumptions. So it was studied by specialists but not integrated into popular understanding of American history. This is changing. Cahokia is now recognised as a UNESCO World Heritage Site. It appears in modern textbooks. Public awareness is growing, but for over a century, despite being the largest pre-Columbian settlement north of Mexico, it was effectively absent from mainstream historical consciousness. The conspiracy theory asks, what else don't we know? What other achievements were documented, then quietly forgotten? What evidence of indigenous technological advancement, astronomical knowledge, or cultural complexity never made it into textbooks because it was inconvenient? Consider another example, the astronomical alignments at Chaco Canyon in New Mexico. Chaco was a major centre of ancestral Puebloan culture from approximately 850 to 1150. Its great houses are precisely aligned with solar and lunar cycles. Structures mark solstices, equinoxes, and lunar standstills with remarkable accuracy. This demonstrates sophisticated astronomical observations sustained over generations. It required detailed record-keeping, mathematical understanding, and engineering precision. Yet for decades, mainstream archaeology attributed these alignments to coincidence, or was simply silent about them. The idea that primitive societies carefully tracked celestial movements made some scholars uncomfortable. It suggested knowledge and sophistication that didn't fit prevailing assumptions. Modern archaeology fully acknowledges Chacoan astronomical knowledge. But for how long was this evidence available but not emphasized? The pattern repeats. Evidence exists of ancient indigenous achievement. Evidence is preserved in museums and academic collections, but evidence is not prominently displayed, not featured in textbooks, not integrated into popular understanding. Is this conspiracy? Not in the traditional sense. It's something more subtle and perhaps more pervasive, cultural bias expressed through curatorial choices made over decades. The Smithsonian didn't destroy evidence of indigenous achievement, but did it choose to emphasize certain narratives while downplaying others? Did it make decisions about what merited prominent display versus storage in archives? And were those decisions influenced, consciously or unconsciously, by prevailing cultural attitudes about indigenous peoples? Modern archaeology is correcting this. Indigenous scholars are reclaiming their history. Collaborative projects between researchers and tribal nations are producing more complete, more accurate accounts of the past. The Smithsonian itself has become more collaborative, more inclusive, more willing to acknowledge indigenous expertise about their own histories. But the question persists. How much time was lost? How many artifacts were categorized incorrectly, stored improperly, or simply ignored because they didn't fit expected narratives? And how would we know what we're missing? If evidence was never prominently displayed, if it never entered public consciousness, if it languished in storage for a century, the effect is the same as if it never existed. This is the power of institutional gatekeeping, not to destroy truth, but to determine which truths receive attention. Chapter 6. Whistleblower Stories. The stories appear on forums, blogs, and alternative research websites with remarkable consistency. Different authors, different time periods, but similar themes. A former Smithsonian curator, speaking on condition of anonymity, claims they were instructed to reclassify certain artifacts to less provocative categories. items initially catalogued as undetermined origin or requires further study were recategorized as natural formation or modern contamination without additional analysis. A researcher who worked in the institution's storage facilities in the 1980s describes being told certain areas were off limits without clear explanation. When they asked about specific catalogue numbers that should have been in those restricted areas, they were redirected to different materials entirely. An archaeologist who submitted findings to Smithsonian journals in the 1990s claims their work was rejected not for methodological flaws but for implications that would confuse the public. The rejection letter, which they claim to have kept but never publicly shared, supposedly stated that while the research was sound, publication would generate more questions than the current evidence base can answer. A museum technician who worked at the Smithsonian in the 2000s reports finding boxes in deep storage labelled with catalogue numbers that didn't appear in digital databases. When they brought this discrepancy to supervisors' attention, they were told the items were awaiting proper cataloguing and not to worry about it. The technician claims they later tried to locate those same boxes and couldn't find them. These accounts are impossible to verify. No names are provided, no documentation is offered. No corroborating witnesses come forward. They exist in that frustrating grey zone between plausible and provable. Could these things have happened? Absolutely. Institutional politics exist everywhere. Museums make curatorial decisions that aren't always transparent. Researchers do face pressure to conform to accepted narratives, but without verification, these stories remain rumour. They prove nothing beyond the fact that people are willing to claim such things occurred, yet they persist and multiply. The pattern of anonymous whistleblower accounts has become part of conspiracy culture around the Smithsonian. The most detailed account comes from a person claiming to be a former Smithsonian anthropologist who worked there in the 1970s. This account has circulated online in various forms for years. According to this story, the individual was assigned to catalogue skeletal remains from southwestern excavations conducted in the 1960s. The remains were from multiple sites, most fitting normal demographic patterns for the cultures and time periods involved. But among the hundreds of specimens, several stood out. The account describes skeletal remains showing unusual proportions, not wildly outside normal ranges, but statistically anomalous. Heights that would have been remarkable for the populations and time periods they supposedly represented. Upon reporting these unusual specimens to supervisors, the whistleblower claims they were initially told to document everything normally. Measurements were taken, photographs were made, preliminary analysis was conducted. But then, according to the account, the unusual specimens were separated from the main collection. They were moved to a different storage area. The individual was informed that further analysis had determined the measurements were erroneous due to bone displacement and mineralization effects. When they asked to see the revised analysis, they were told it was handled by senior staff and wasn't available for review. The unusual specimens were reclassified as within normal variation. The original measurements were noted as preliminary and superseded. No further study was conducted that the whistleblower was aware of. The specimens were filed away. The catalogue entries made no mention of the initial unusual findings. The account continues. When this individual asked colleagues about the situation, they were told, off the record, that the institution had guidelines about what kinds of claims could be made based on skeletal evidence. Extraordinary measurements required extraordinary context and documentation. Without clear provenance and supporting evidence, it was better to err on the side of conservative interpretation. One supervisor allegedly told them, "We don't have context for these anomalies. Without context, they create more confusion than clarity. Our job is to educate the public, not generate sensational headlines." The whistleblower claims they remained at the Smithsonian for several more years, but grew increasingly uncomfortable with what they perceived as unwillingness to pursue uncomfortable questions. They eventually left for a position elsewhere and later shared their story anonymously. Is this account real? There's no way to confirm it. The level of detail suggests someone with genuine institutional knowledge. The described procedures sound plausible for how large museums operate. But it could also be complete fabrication by someone familiar with museum operations, creating a story that sounds authentic without being verifiable. This is the essential problem with whistleblower accounts. They exist in the absence of hard evidence. They appeal to people already suspicious of institutions. They confirm existing beliefs rather than challenging them. And yet, complete dismissal seems unwarranted. Institutions do sometimes prioritize reputation over transparency. Scientists do face pressure to conform. Curatorial decisions are sometimes made for political or practical reasons rather than purely scientific ones. The truth probably lies somewhere between conspiracy and complete innocence. Not deliberate destruction of evidence, but a culture that favours certain kinds of findings over others. Not malicious cover-up, but selective attention driven by unconscious bias and institutional inertia. That's actually more concerning than cartoon villainy, because it's harder to address and easier to deny. Chapter 7. Why the Smithsonian is targeted. Why does the Smithsonian attract these conspiracy theories while other museums largely escape similar accusations? The answer lies in the institution's unique position within American cultural and scientific infrastructure. The Smithsonian isn't just another museum. It's the museum. It's a federal institution, with authority and resources unmatched by any private collection. It sets standards for museum practice nationwide. It influences educational curricula. Its conclusions shape textbooks, documentaries, and public understanding of history and science. When the Smithsonian makes a determination about an artifact's age, origin, or significance, that determination carries weight across the entire field. Other institutions defer to Smithsonian expertise. Publishers rely on Smithsonian research. Teachers present Smithsonian conclusions as established fact. This creates enormous responsibility, and responsibility creates pressure. The institution holds more American archaeological and anthropological material than any other organisation. If something was discovered in the United States and deemed scientifically significant in the last century and a half, there's a substantial probability it ended up in Smithsonian collections. This creates a paradox. The organisation most capable of preserving and studying controversial evidence is also the organisation most invested in established narratives. It has the most to lose from paradigm shifts that would invalidate decades of previous work, publications, and institutional positions. Think about the incentive structure. You're a Smithsonian curator with decades of experience. You've published extensively on the peopling of the Americas, arguing for the Clovis first model, which suggested humans arrived in the Americas around 13,000 years ago, via the Bering Land Bridge. Then evidence emerges suggesting much earlier human presence. Monteverde in Chile, dated to 14,500 years ago. Pre-Clovis sites in North America. Genetic evidence suggesting multiple migration waves. This evidence contradicts your life's work. Do you immediately embrace the new findings and acknowledge your previous conclusions were wrong? Subject the new evidence to rigorous scrutiny, looking for methodological flaws? Resist paradigm change until the evidence becomes absolutely overwhelming? Most scientists choose option 2, which is actually appropriate. Extraordinary claims should face rigorous examination, but there's a fine line between healthy skepticism and entrenched resistance. And when an entire institution has built its reputation on certain historical narratives, that line becomes even harder to navigate. The Smithsonian is also tied to government, which amplifies conspiracy thinking. It's formally a trust instrumentality of the United States, created by Congress and partially funded through federal appropriations. This connection to government makes it a target for people who generally distrust federal institutions. If you believe the government routinely lies to citizens about significant matters, why wouldn't that extend to the Smithsonian? If cover-ups occur in national security or politics, why not in archaeology? The theory becomes less about specific malicious acts and more about institutional inertia and risk avoidance. Consider a scenario. A donor brings an artifact to the Smithsonian. It's unusual. Initial analysis suggests it might challenge accepted timelines for technological development in ancient cultures. But the provenance is unclear. The context is ambiguous. You, as a curator, have several options. Display it prominently, acknowledging uncertainty but inviting public engagement with the mystery. study it extensively, committing significant resources to what might ultimately prove to be a misidentified or contaminated specimen. Catalogue it conservatively, note the uncertainties, and store it for potential future study when better analytical methods might be available. Set it aside as insufficiently documented to merit serious attention. Which choice serves the institution's mission of education and research? Which serves your career advancement? Which protects the institution's reputation for scientific rigour? Which creates the least immediate disruption? In most cases, the conservative choice wins, not because of conspiracy, but because of bureaucracy, because of limited resources and competing priorities, because of reputational concerns and risk aversion. And over decades, those individual conservative choices accumulate. They create patterns. They generate gaps between what exists in collections and what receives attention. And gaps, once noticed by persistent researchers, fuel conspiracy theories. The Smithsonian also suffers from its own success. Its collections are so vast, 140 million items, that complete organisation and accessibility is nearly impossible. Even with modern database technology, materials slip through cracks. Catalogue numbers don't match physical locations. Items are stored in facilities that don't have comprehensive digital inventories. This ordinary chaos of managing massive collections becomes sinister when researchers can't find specific items they're looking for. The mundane explanation is, the collections are huge and imperfectly organised. The conspiratorial explanation is, items were deliberately hidden or removed. Both might be partially true. The collections are huge and imperfectly organised, and some items were probably deliberately set aside, not out of conspiracy, but out of curatorial judgment about what merited limited resources and attention. The institution has also made genuine mistakes throughout its history. It's displayed forgeries as authentic artifacts. It's made claims about human evolution that later proved incorrect. It's supported now debunked theories about ancient cultures. These mistakes are actually evidence that science works through self-correction. They show the institution is capable of admitting error and updating positions based on new evidence. But they also demonstrate fallibility. And once people realise an authority is fallible, trust becomes conditional rather than automatic. The Smithsonian conspiracy theories endure because the institution occupies a unique position combining enormous authority over historical narratives, federal government connection, vast collections with inevitable organisational imperfections, history of genuine mistakes and course corrections, incentive structures that favour conservative interpretations. This combination makes it a natural target for conspiracy thinking, regardless of whether actual conspiratorial behaviour has occurred. Chapter 8. Official Responses and Rebuttals. The Smithsonian Institution has addressed these conspiracy theories multiple times over the decades, with increasing frustration as the internet age has amplified their spread. Their official position is remarkably consistent. The institution does not destroy evidence for ideological or political reasons. The institution does not hide artifacts that challenge established theories. The institution applies rigorous scientific standards to all specimens, and extraordinary claims require extraordinary evidence. When conspiracy theorists point to 19th century, newspaper accounts of giant skeletons, Smithsonian representatives and mainstream archaeologists respond with several counter-arguments. First, early American archaeology lacked professional standards. Most excavations were conducted by amateurs with no formal training. Measurements were frequently inaccurate. Documentation was poor or non-existent. When a 19th century newspaper reports a skeleton measuring 9 feet, modern archaeologists ask, who measured it? What methods were used? Was the skeleton complete or reconstructed from fragments? Were the bones properly identified as human rather than animal remains? In most cases, these basic questions cannot be answered because the documentation doesn't exist. The newspaper reports offer sensational claims without methodological detail. Second, there are numerous documented cases of misidentification. Large animal bones were frequently mistaken for giant human remains. Mastodons, mammoths, and large extinct mammals left bones that could appear human to untrained observers. The giant skull, discovered in Missouri in 1894, initially reported as evidence of an ancient race of giants, was later identified as belonging to a cave bear. The finder was genuinely convinced it was human, but expert analysis proved otherwise. Without the actual bones available for modern analysis, we cannot know how many giant skeleton reports were similar misidentifications. Third, geological and biological processes can create illusions of greater size. Bones can be displaced by soil movement, making scattered remains appear to represent a larger individual than they actually do. Mineralization can cause bones to expand. Decomposition can separate remains in ways that suggest greater dimensions. Fourth, hoaxes were common. The Cardiff giant, the Piltdown Man, numerous other fraudulent discoveries fooled respected scientists in their time. If trained observers could be deceived by deliberate fakes, how much easier would it be for amateurs to misinterpret genuine remains? The absence of these giant skeletons in current collections has mundane explanations. They never existed as described. They were animal bones misidentified as human. They were normal human remains measured incorrectly. They were hoaxes. They were destroyed in fires, floods, or other disasters that affected museum collections. They were lost during one of the Smithsonian's several relocations and reorganizations. They were deaccessioned when provenance could not be verified. Any of these explanations is more probable than deliberate destruction to hide evidence. When conspiracy theorists claim specific artifacts have disappeared, Smithsonian archivists point out the realities of managing historical collections. The institution has accessioned materials for over 175 years. Early catalogue systems were inconsistent. Items were sometimes recorded under descriptions that don't match modern search. Terms, storage locations changed multiple times. Different departments used different numbering systems. Finding a specific artifact from a 19th century accession can be genuinely difficult, even for staff with full access to collections and databases. This doesn't mean the item was hidden. It means institutional memory is imperfect, and early record keeping was inadequate by modern standards. Additionally, museums regularly deaccession materials. This isn't destruction of evidence, it's responsible collection management. Items are deaccessioned when provenance cannot be verified. The item is a duplicate of better specimens already in the collection. The item is deteriorating beyond conservation capacity. The item was misidentified and doesn't actually represent what it was catalogued as. The item is more appropriate for a different institution's collection. These decisions are documented and reviewable. They're not secret, but they do mean that not everything ever accessioned remains permanently in the collection. When critics claim the institution downplays evidence of advanced ancient technology, archaeologists offer context. Ancient civilizations were sophisticated. This is acknowledged and celebrated. But sophistication doesn't mean they possess knowledge or technology beyond what we can demonstrate through evidence. The precision of Egyptian engineering is remarkable, but experimental archaeology has shown that proposed ancient methods could achieve similar results given sufficient time and labour. The Antikythera mechanism is extraordinary, but it's an outlier. We have no other examples of similar devices from that period, suggesting it was exceptional rather than representative of general technological capabilities. The Baghdad battery might have generated current, but that doesn't prove systematic understanding of electricity. It could be coincidental electrochemistry from a device designed for different purposes. The mainstream position isn't that ancient people were primitive, it's that we need solid evidence before attributing capabilities to them. Speculation should be clearly identified as such, rather than presented as fact. Regarding Indigenous history, the Smithsonian has acknowledged past failures to adequately recognise and display pre-Columbian achievements. Modern exhibits have corrected this. Collaborative programs with tribal nations have expanded. Indigenous voices are increasingly centred in interpretation of their own histories. These changes demonstrate institutional willingness to evolve and acknowledge past shortcomings. They show the Smithsonian responding to legitimate criticism. But conspiracy theorists interpret even these positive changes differently. They see them as admissions that evidence was previously suppressed. If the institution now acknowledges greater indigenous sophistication, Doesn't that prove they were downplaying it before? The Smithsonian's response: understanding evolves. New research produces new insights. Changing interpretations reflects scientific progress, not previous conspiracy. When confronted with whistleblower accounts, the institution cannot respond to unverified, anonymous claims. If someone has evidence of wrongdoing, they should present it through proper channels. Anonymous forum posts prove nothing. The overall Smithsonian position boils down to science is a process. Our understanding of the past is constantly being refined. Mistakes have been made and corrected. But there is no systematic effort to hide evidence or suppress truth. Archaeologists argue that extraordinary claims require extraordinary evidence. If someone claims 10-foot-tall humans once lived in North America, we need more than newspaper clippings. We need bones, measurements, DNA analysis, and contextual evidence. If someone claims ancient Americans had advanced technology far beyond what we currently understand, we need artifacts that cannot be explained through known capabilities. Absence of such evidence, despite extensive archaeological work across the Americas, suggests the claims are unfounded. But for conspiracy theorists, official denials only deepen suspicion. Of course, the institution would deny wrongdoing. What else would they say? This is the impossible position institutions face when accused of conspiracy. Evidence of innocence can be dismissed as cover-up. Lack of evidence for conspiracy can be explained as successful concealment. The argument becomes unfalsifiable, and unfalsifiable claims aren't science, they're faith. Chapter 9. Why the Theory Endures. The Smithsonian conspiracy theory persists not primarily because of evidence, but because of context, because of how it fits into broader patterns of institutional distrust, because of how it answers uncomfortable questions, because it offers simple explanations for complex realities. Several factors ensure the theory's continued vitality despite lack of proof. First, early American archaeology did lack standards. This is historical fact. Before professional archaeology developed as a discipline in the early 20th century, excavation techniques were crude. Documentation was inconsistent or non-existent. Amateur enthusiasts conducted digs with no scientific training. Farmers unearthed burial mounds looking for valuables. Collectors hired labourers to dig for artefacts without recording context. Newspapers reported sensational finds without verification. This chaotic early period created a documentary record full of questionable claims, exaggerations, and outright frauds. Some of this material is now recognisable as false, but some sits in an ambiguous zone where we can neither prove nor disprove the claims. That ambiguity breeds speculation. If we can't definitively say certain reports were wrong, maybe they were right. And if they were right, where did the evidence go? Second, museums historically did make mistakes. They displayed forgeries. They supported incorrect theories. They made claims that later proved embarrassing. The Smithsonian exhibited the Cardiff Giant before it was proven to be a hoax. The institution supported now discredited theories about human evolution. It displayed archaeological interpretations that subsequent research contradicted. These are actually signs that science works through self-correction. They demonstrate that institutions can admit error and update positions. But they also demonstrate fallibility. And once people realise an authority can be wrong, every claim becomes potentially questionable. Third, real cover-ups have occurred in other contexts, fueling generalised distrust. Governments have hidden information about military experiments, environmental contamination, and public health risks. Corporations have suppressed research about product safety. Scientific institutions have at times been slow to acknowledge findings that challenged powerful interests. The Tuskegee syphilis experiment, tobacco industry research manipulation, pharmaceutical companies hiding adverse trial results. These proven conspiracies establish that institutions can and do conceal truth when motivated to do so. So when conspiracy theorists look at the Smithsonian, they reason, if cover-ups happen in medicine and industry and government, why not in archaeology? What makes museums immune to the same pressures? Fourth, genuine mysteries remain unsolved. Ancient engineering feats we don't fully understand. artifacts that don't fit neatly into established timelines, cultural achievements that seem advanced for their supposed technological context. Mainstream archaeology offers explanations, but they sometimes feel incomplete. They require imagining capabilities we can't quite reconstruct. They involve lost techniques we can only theorize about. In that gap between achievement and explanation, conspiracy theories flourish. If we don't know exactly how they did it, maybe they had help we're not acknowledging. Maybe evidence of that help has been suppressed. Fifth, the absence of proof becomes part of the narrative. If the Smithsonian isn't hiding anything, conspiracy theorists ask, why can't they produce the giant skeletons mentioned in those newspaper accounts? Why aren't the artifacts from old expedition reports available for study? The official answer is reasonable. The items probably never existed as described, or they were destroyed through ordinary causes, or they're simply lost in vast, imperfectly organised collections. But conspiracy theorists hear they existed and someone made them disappear. This is the insidious logic of conspiracy thinking. Any gap in the record becomes potential evidence. Any missing data suggests intentional concealment. Absence of proof is reframed as proof of absence. Sixth, the theory is emotionally satisfying. It provides simple answers to complex questions. It creates villains and heroes. It suggests that truth is being suppressed but can be recovered through persistent investigation. It's more comfortable to believe in conspiracy than to accept that. Much of the past is genuinely unknowable. Documentary evidence is often unreliable. Our understanding is incomplete and uncertain. Some mysteries may never be solved. Conspiracy offers certainty. It says, we would know the truth if they hadn't hidden it. The knowledge exists, just concealed. This is psychologically easier than accepting fundamental uncertainty. Seventh, the internet has amplified and preserved conspiracy claims, while making authoritative rebuttals seem like just another opinion. Before the internet, conspiracy theories spread through books and word of mouth. They faced gatekeepers, publishers, librarians, educators who could evaluate credibility. Now, a blog post claiming Smithsonian cover-ups has the same accessibility as an official institutional statement, actually often more accessibility because conspiracy content is engineered for engagement while official responses are written in careful academic language. Search algorithms can't evaluate truth. They evaluate popularity and relevance. If thousands of people share a conspiracy claim, it rises in search results regardless of accuracy. Young people researching topics for school and counter-conspiracy websites alongside authoritative sources. Without training in source evaluation, how do they distinguish between them? Eighth, the conspiracy theory serves political and ideological purposes for some believers. For those who reject mainstream science on religious grounds, evidence that scientific authorities are unreliable supports their worldview. If the Smithsonian hides giant skeletons mentioned in the Bible, this confirms that secular science cannot be trusted. For those who oppose government and federal institutions on principle, the Smithsonian as a federal entity makes an appealing target. Proving federal dishonesty in one area justifies distrust in all areas. For those who feel marginalized by academic culture, conspiracy theories offer a way to claim superior knowledge. I know the truth that experts hide. These motivations ensure the theory's persistence regardless of evidence. The tragedy is that some legitimate questions get lost in conspiracy noise. Questions about how curatorial decisions are made and whether they involve unconscious bias. How institutional culture affects which research questions receive attention and resources. How gaps in historical knowledge should be acknowledged and communicated. How to balance certainty and uncertainty in public education. These are important questions worthy of serious discussion, but they get overshadowed by claims of deliberate deception and hidden giants. The Smithsonian conspiracy theory endures because it offers what humans crave: simple explanations, clear villains, and the promise that truth is just hidden, not genuinely unknown. Reality is messier, truth is harder. Chapter 10. Truth, Trust, and Institutions. Strip away the allegations about giants and lost civilizations. Remove the claims of destroyed evidence and hidden artifacts. What remains is a deeper, more fundamental question that the conspiracy theories dance around without directly addressing. Who do we trust to tell history? And what happens when that trust proves conditional? The Smithsonian Institution shapes how millions of Americans understand the past. Its exhibits become common knowledge, the background facts that educated people are expected to know. Its publications influence textbooks that shape what children learn. Its researchers appear in documentaries, offering expert testimony that carries the weight of institutional authority. This is enormous power. Power to define what is important and what is trivial. Power to determine which narratives enter public consciousness and which remain known only to specialists. Power to shape collective memory. But authority is not infallibility, and trust should not mean blind acceptance. Institutions are made of people. People have biases, blind spots, career incentives, and social pressures. People make decisions based not only on evidence but on feasibility, palatability, and institutional priorities. Organisations develop cultures. Some questions become acceptable to ask, others uncomfortable. Some conclusions are easy to support, others require defending against sceptical colleagues. Some research directions receive funding and encouragement, others face obstacles. This doesn't make institutions evil, it makes them human. And humanity involves limitation. The conspiracy theories about the Smithsonian often miss this nuance. They imagine a shadowy group deliberately hiding truth, making conscious decisions to deceive the public. The reality is probably more mundane and in some ways more troubling. Not conspiracy, but culture. A culture that values consensus over disruption. That prefers established narratives over unsettling questions. That makes conservative choices about what to emphasise and what to set aside. Over time, those individual choices accumulate. They create a version of history that is coherent, comfortable, and teachable. But is it complete? Is it accurate in all its particulars? Or does it sometimes smooth over complications, avoid uncertainties, and privilege certain stories over others? We know the Smithsonian has changed its positions before. Archaeological understanding has evolved. Theories once considered mainstream are now rejected. Evidence once dismissed has been re-evaluated and accepted. The Clovis First model, which held that humans first arrived in the Americas around 13,000 years ago, was institutionally supported for decades. Evidence of earlier occupation was viewed sceptically. Sites suggesting pre-Clovis presence faced extraordinary scrutiny. Then accumulating evidence became overwhelming. Monteverde in Chile, genetic data showing multiple migration waves, pre-Clovis artifacts in North America. The paradigm shifted. Institutions, including the Smithsonian, adjusted their positions. This is how science should work. Self-correction through new evidence and better methods. But it also means what institutions tell us today is subject to revision tomorrow. What we're told is established fact might be updated or overturned in the future. If institutions can be wrong, the question becomes, how do we know when they are? How do we distinguish between legitimate scientific consensus and institutional inertia protecting incorrect conclusions? This is genuinely difficult. We cannot all become experts in every field. We must rely on authorities. But uncritical reliance creates vulnerability to institutional mistakes and biases. The healthy middle path involves respecting expertise while maintaining critical awareness, trusting institutional knowledge while understanding its limitations, accepting scientific consensus as the best current understanding while remaining open to revision, distinguishing between conspiracy theories and legitimate critiques of institutional practices. This requires nuance. It requires holding seemingly contradictory ideas simultaneously. Institutions deserve scrutiny and their claims should be questioned. And also, extraordinary claims require extraordinary evidence, and skepticism applies to conspiracy theories too. The Smithsonian's darkest secret might not be hidden artifacts or destroyed evidence. It might be something simpler and more universal. The impossibility of perfect transparency in an institution managing millions of items, nearly 2 centuries of history, and the weight of public expectation. How can any organisation be fully accountable when the task itself is overwhelming? How can curators document every decision when making thousands daily? How can researchers address every anomaly when resources are limited and priorities must be set? The gaps in the record aren't necessarily evidence of conspiracy. They might be evidence of limitation, of the inevitable imperfections of any human endeavour operating at massive scale across generations. But limitation can enable concealment. Disorganisation can achieve what conspiracy would require, and we cannot easily distinguish between innocent chaos and deliberate obscuration from outside the institution. This uncertainty is uncomfortable. We want clear answers. We want to know whether to trust or distrust. We want institutions to be either reliable authorities or proven frauds. Reality offers neither certainty. Institutions are fallible but often reliable, sometimes wrong but frequently right, deserving of trust but requiring oversight. The conspiracy theories offer escape from this ambiguity. They promise that truth is clear, just hidden. They suggest that uncertainty is manufactured rather than inherent. But the real world is uncertain. The past is fragmentary. Our knowledge is incomplete and probably always will be. The question isn't whether the Smithsonian is perfectly trustworthy. No institution is. The question is whether it operates with reasonable integrity, corrects mistakes when identified, and serves its stated mission of preserving and sharing knowledge despite inevitable human limitations. The evidence suggests it does, imperfectly but genuinely. The conspiracy theories suggest it doesn't, perfectly and deliberately. Which interpretation fits the available evidence better? Which is more consistent with how institutions actually function? The truth, as usual, resists simplicity. Epilogue: the locked vault question. Deep in the Smithsonian storage facilities, there are rooms most visitors never see, will never see, cannot see without explicit permission and documented research purpose. Rows of metal shelving holding thousands of cardboard boxes, climate-controlled spaces preserving fragile specimens from light, moisture and temperature fluctuations, cabinets filled with items waiting for study, cataloguing, or simply space in public galleries that may never come. The institution holds 140 million objects. This number is almost incomprehensible. If you spent 1 second looking at each item, it would take over 4.5 years of continuous observation without sleep. Only a tiny fraction is ever displayed. Most sit in storage, accessible to researchers by appointment, but invisible to the general public. Out of sight, out of mind. What's in those boxes? Mostly the expected. Pottery shards catalogued by culture and approximate date. Stone tools labelled by type and location. Skeletal remains stored according to established protocols. Textile fragments preserved in acid-free containers. The ordinary artefacts of ordinary lives, collectively telling stories about how people lived, worked, created and died. But also inevitably anomalies. Things that don't fit neat categories. Items with unclear provenance that make definitive conclusions difficult. Specimens that raise more questions than they answer. Questions that current methodologies cannot adequately address. Some of these anomalies get studied. Grad students write dissertations. Papers appear in specialised journals. Mysteries get solved or at least better understood. The anomaly becomes integrated into knowledge, explained and categorised. Some sit, waiting for the right scholar with the right question, waiting for new analytical technology that might reveal secrets current methods cannot detect, waiting for someone to notice them among millions of other items competing for attention. And some, perhaps, are simply forgotten, not destroyed, not hidden, not deliberately concealed, just overlooked, set aside and never retrieved. Lost in the vast bureaucracy of an organisation managing more material than any human mind can fully grasp. The conspiracy. Theory imagines intention, a deliberate choice to conceal. Curators meeting in shadowy rooms, deciding what truth the public can handle. Artefacts quietly destroyed to protect established narratives. The reality might be more banal and somehow more troubling. Neglect. the passive erasure that comes from having too much to manage and too few resources to manage it, the slow forgetting that happens when things sit unopened in boxes for decades. Either way, the effect approaches similarity. If something didn't fit the story of human history, if it challenged our understanding in ways we weren't ready to confront, if it required explanation that current paradigms couldn't provide, would we know if it disappeared into those storage rooms? Would we know if it was catalogued under a description that doesn't capture its significance? Filed in a location that makes it unlikely to be found? Assigned to a box that hasn't been opened since it was sealed decades ago? The Smithsonian maintains it operates with integrity. Its researchers are scientists, not censors. Its mission is knowledge, not narrative control. Its purpose is preserving truth, not concealing it. And they're probably right, in the overwhelming majority of cases, for the vast majority of decisions made daily by people trying their best under difficult circumstances, but probably and mostly an overwhelming majority are not the same as certainly and always in every single case. The institution remains largely silent on specific conspiracy claims. It doesn't engage extensively with allegations it considers baseless. It lets its scientific work speak for itself. It maintains that those seeking evidence of wrongdoing will find none because none exists. The debate continues regardless, not because of evidence which remains absent, but because of doubt, which once planted grows deeper roots than any fact. And doubt has many sources: the documented gaps in records, the missing artifacts, described in century-old reports, the patterns of what receives attention versus what doesn't, the natural human tendency to distrust concentrated authority, the genuine mysteries that remain unexplained, the history of mistakes and course corrections, the simple fact that perfect transparency is impossible in any institution of this scale. In the end, we're left with questions that may never find definitive answers. Do we trust institutions to tell us the truth about the past? Can we trust them, given that they're human enterprises subject to all the failings humanity entails? Do we believe that everything discovered has been preserved and honestly presented? Do we accept that our understanding of history might be incomplete, not from conspiracy, but from the simple limitations of human knowledge and institutional capacity? Or do we wonder what sits in those boxes no one opens? What lies forgotten in storage areas that haven't been fully inventoried? What truths might be waiting in plain sight, catalogued too vaguely to be found? The Smithsonian's doors remain open. Its collections are vast. Its researchers welcome serious inquiry from qualified scholars. It has processes for access, review, and study. But the vaults are deep. The records are incomplete. The collections are massive beyond full comprehension. And the past, once gone, speaks only through what we choose to preserve and how we choose to interpret it. These choices, made over decades by thousands of individuals operating within institutional cultures and constraints, have shaped what we know and what we don't. Whether those choices were always made with perfect integrity, whether they were free from bias and political pressure, whether they prioritized truth over comfort in every instance, we cannot know with certainty from outside the institution. We can examine the evidence, evaluate the arguments, and reach conclusions about what seems most probable. But absolute certainty escapes us. As it does in most things worth thinking about deeply, sleep well tonight. And remember, history is written by those who control the archives. And sometimes, the most important question isn't what we know. It's what we'll never know we lost. The boxes sit in climate-controlled darkness, their contents waiting, their stories untold. Perhaps someday, someone will open them. Perhaps they already have, and found nothing of significance. Or perhaps they found something that changed everything, and we simply haven't heard about it yet. The vaults keep their secrets, and we are left to wonder